Mesdames et messieurs, meine Damen und Herren, ladies and gentlemen, welcome to this FABEC Environment Day. And welcome in particular to those who are physically here in Geneva, actually being physically together after what seems like forever. It's apparently only 1.5 years, but it really is quite an extraordinary thing, and I'm very, very pleased to see that many people here. Welcome to those of you who are online, either at home, in home office, or in your offices, wherever you are. Thank you for joining us as well, and we hope to take our way through today and make it interesting and try and give a lot of different inputs and insights on FABEC and how FABEC is looking at the challenges which the environment present towards us. Inside this room, the rule is if you're seated at least 2 seats away from somebody else, you may take your mask off. And fairly obviously, the speakers will be taking their masks off, because otherwise it's rather difficult to understand what the speakers are saying and defeats the purpose of the exercise, rather. So today, we'll just do quick safety and health. That was the first part of the health. When we're moving around, we put our masks back on if we can't guarantee the 2-meter rule until we sit down for lunch, when the rules are slightly different again in the restaurant. In the event of a fire alarm, which there are none planned, we're out that door there, immediate turn right back, and then the master place is off up the road in that direction. For those of you at home, you don't need to know that, but if you want to show solidarity by wearing your masks at home, you're very welcome to do that, of course, as well. For those of us who are here, we will then hopefully be going through a quite exciting day of inputs. First of all, with an introduction from Marcel, whom I will hand over to in a moment, and from our minister. Then into presentations from people here in the room, and there are a number of different perspectives that we'll be looking at. After lunch, one more presentation, and then a good panel session, and very grateful to all of the people who have given their time to come and join us, either as a presenter or as a panelist. On our way through that as well, we're hoping for interaction with the audience. Obviously, those who are here, that's relatively easy to do. And for those of you at home, we are using Slido as well. So if you are at home and wish to ask a question or make a comment for the panel or the presenters, then the Slido.com is the place to go. And in some seconds, and every now and then, you will also see the Slido log-on coming up on the screen for you as well. And there we go. So #EnvDay, and you should be able to join, place your questions, and Raymond will then be moderating those, taking any ones that we don't want to see out, and just giving, hopefully, the teams the questions that we can answer. Or maybe the questions that we can't answer, because actually it's the unanswerables that give us our biggest challenge at the moment, because there are so many unknowns and so many trade-offs that we don't know whether today's trade-off is the right thing for tomorrow. And we'll pick up on that a lot more during the day. With that, I would like to hand over to Marcel Zuckschwert, who is the chairman of the FABEC Council for this year. He is also the Deputy Director of the Federal Office of Civil Aviation, the Civil Aviation Authority in Switzerland. And he's also, by dint of that, he's also the Deputy Director General of Civil Aviation in Switzerland. Marcel, the microphone and the floor are yours.
So thank you, Alex. Ladies and gentlemen, as chairman of the FABEC Council, it's a great pleasure to host this Environmental Day. And also from my side, I would like to warmly welcome all participants, those attending the meeting here physically or remotely by video conference. This Environmental Day is the result of a joint initiative of the FABEC Council Presidency and the FABEC ANSP Strategic Board Presidency with Alex. We decided to make environment one of our priority during our year of presidency. Indeed, societal expectations and the various objectives at global, European, state, or industrial level in this domain are a reality, and we must give a credible answer to these expectations, even with the current crisis. Building back after the crisis also means that we look for ways in our sector how these environmental objectives can be best achieved. We all have to contribute. That being said, I would like to stress that the topic of environment is not new. All partners of the aviation chain worked hard in the last years to reduce the environment footprint of aviation, and concerning air navigation services, we have already improved towards an excellent level. This does not mean that we cannot improve further. Today's main objective is to assess the current situation, which measures are already being taken, and where is potential for further improvement. We will also look at the challenges and the interdependencies that influence the environmental performance of ATM. Ladies and gentlemen, on behalf of FABEC, I am looking forward to some fruitful discussions. Now, before giving back the floor to Alex, it's my honor to present you the opening statement by Federal Council Sommaruga, our Swiss Minister of Transport and Environment. Thank you.
Dear participants of this meeting, ladies and gentlemen, on behalf of Switzerland's presidency of FABEC, it is my pleasure to welcome you to this Environmental Day organized by FABEC. Today, you will discuss how air traffic management can contribute to reduce the environmental impact of air transport. I am delighted that you have chosen this topic. Aviation has a responsibility in climate protection. Air transport is challenged to find new ways of making mobility smarter, greener, and future-proof. People expect the civil aviation to become more sustainable, therefore we have to find solutions. The recovery from the COVID-19 pandemic will be a unique opportunity to do things differently and better. In the past, aviation has demonstrated that it has been an innovative industry, also when it comes to environmental protection. The improvements in terms of reducing noise and emissions are remarkable. They show aviation's willingness and ability to develop new technologies and procedures. I hope and expect these innovations in the service of the environment and the population continue to develop. It is our common responsibility. We cannot afford to lose time more on this topic. I wish you fruitful discussions. Thank you.
And thank you to Federal Councillor Sommaruga as well, who incidentally last year was the president of the Swiss Confederation as well. So she has in her ministerial portfolio both transport, so the aviation community, and the environment. And so she really knows what she's talking about when she's trying to find the right balance at a political level and at a pragmatic level about what's going on and what we need to do. It's now my great pleasure to hand over to the first speaker for today, and that first speaker is John Santabano, who is the director of the Maastricht Upper Area Centre in Maastricht, funnily enough, and he is also this year the vice chairman of the strategy board, so the vice chairman of my role, which he will take over at the beginning of next year, and he is also More specifically and more directly relevant, he is the CEO champion for the environment, and therefore the person that we would like to hand over to start us, to really kick us off this morning. John.
Thank you, Alex. So I welcome you to the FABEC Environmental Day today, and I'm really glad that we are not imprisoned anymore. And I think after 15 or more than 15 months, it's really a pleasure to meet again and to start with this topic. So today we will not talk about costs, about revised RP3 planning or recovery. We talk about environment, and I think that is also an important sign from FABEC to focus on this topic, because we take it seriously and we are all aware that neither society, neither politics, nobody will allow us not to deliver on that, and that's why it's of great importance. So I think all of us, we experienced these last 15 months by not traveling at all, or maybe adapting the way we are traveling, and I think we cannot go back to business as usual. It's, as it was said already, it is also expected from us that we improve, and that we are not asked not to travel anymore, and we are not asked to do aviation bashing, but we are asked to rethink in a green way, in a ecological, sustainable way, to redefine the way we are assuring transport and services. And I'm convinced that this is possible. This is, of course, even more possible if we have the support of new technologies. So we are all aware that we need a radical improvement and support and help from industry, and I can call it sustainable fuels or fuel cell propulsion done by electric or even hydrogen solutions, or maybe more engine technologies. I think all partners have to adhere and to cooperate in order to make it happen. And I have to say, if I take an example, the roadmap destination 2050, which goes for zero net CO2 emission for 2050, is a good example where there is a commitment from industry, from airlines, from airports, from politics, from all the people who might deliver best effort to do so. We, of course, in FABEC, we might not influence considerably the greenhouse effect of aviation and the emissions, but nevertheless, I think everybody should do his utmost, and we should more go for qualitative targets than for quantitative targets, and we should evaluate the best effort, as I said, of all partners. And it's not depending who is delivering more or little, it's depending who delivers what he is able to deliver. So in the CESAR program, together with the network manager and the ANSPs, we improved a lot the free route project. So we shortened the flights, we reduced the fuel consumption, and indirectly, of course, we had also a positive influence on the environmental impact of aviation. We noticed already before the pandemic crisis changes in society, and I was talking about flight shame, but independently from that, I think we have to acknowledge and to accept that our society, our children, and our governments, our politics expect us to redefine in an ecological, proper way transport in aviation. In its EASA Urban Air Mobility Survey, when implementing electric air taxis in European cities, we noticed that citizens have been more caring about and looking at the environmental consequences and impacts than on safety issues, for example. So that shows that our society really expects us to go for a paradigm change. On the other hand, as ANSPs, we have to know that we are focusing, of course, on the performance scheme, and the regulators and the Commission ask us to deliver when it comes to capacity, to delays, and to the cost of services. Good job, and we get penalties if we don't do so. So in that sense, we should also maybe think about incentives when it comes to environmental performance, which today, in that sense, when it comes to KPIs and performance indicators, do not exist in a similar way. Together with the network manager, we are all aware that traffic will increase again, the recovery will come, and we are also glad about this and happy about this. But on the other hand, we know that more traffic will also mean automatically more emissions. So we have to find a solution, not only on the technological way, but also on the airspace design solution, which we worked a lot at. I mentioned already the free route, but I could also tell you that we reduced by 600 the number of route restrictions, that we managed in FABEC to introduce free route in many of the important European airspaces. This means for 2020, for instance, a minus of 1.4 million tons of CO2. The horizontal flight efficiency is reaching 97%, so nearly an optimization of the trajectory. We improved continuous descent and performance-based navigation. A good example is the airport of Charles de Gaulle. We focused a lot and improved on the functional use of air blocks between military and civil aviation. I think that the idea is that we use the limited airspace in a more intelligent way by communicating and by coordinating together and by sharing this when feasible. Maybe I should mention that we also got awarded several times. I can just mention the Xtreme project, where we got awarded for research and innovation and environmental solutions. But this does not mean that we should stop at this level. A really important step was taken 4 weeks ago when the European Transport Council met, and when the transport ministers unanimously decided the following: environmental consideration should, like safety, be a priority when planning and assessing the performance of ANSPs. So they really want to go for a reform of the single European sky, and they want us to protect and not only safety in our airspace, but to also protect the environment. So meaning we do not need only to assure safe operations, but we need to assure that our airspace stays environmentally seen in the best shape as possible, if I may say like this. That means what? That means for us a completely change of our business. We need to rely on other partners. We have to understand the other partners, all the actors. We have to focus on training. We have to adapt and to introduce new regulations. We have to understand the needs of each other, and we have to see the flight as a whole. That's the ominous gate-to-gate approach. So what happens on the ground, on the taxiway, what happens in the climb, in the descent, what happens in the lower airspace, what happens in the upper airspace. So it does not make sense that one or two deliver when others might be weak, or the other way around. So that shows as a good example the importance that we can just manage if we do it together, and if we understand the needs and the requirements of each other. Sorry. We will have to go for a balance between capacity and environment. So this will be important, that there we will get the right guidance. Thank you. You are saving me. The right guidance and the right prioritization also from those who take decisions. Parallelly to this, I think the COVID crisis also showed that we as ANSPs have to be resilient, to react quickly, and to deliver state-of-the-art services, and independently from the market pressure which is prevailing. And I think we did rather well, but I think for many of us it was a surreal situation we didn't expect. As I said, we asked for clarification on some items. For instance, we need to know, for instance, for 2025, for the new performance scheme, will we there also integrate, and I guess that yes, the environmental aspects with KPIs and with performance indicators together with safety. There will be a trade-off between traffic volume and environmental impact. So there, of course, we need proper guidelines. And I would say that we have to take care that those who invest, for instance, more money in their services to be environmental green should also not be penalized because of that. That's one of many questions we should solve, and we should also protect those who are early movers, if I might say. Industry-wide, we need to define a basic matrix. So we need to have proper data in order to assess what is the environmental footprint of the actors and what are the possible improvements. So if we cannot measure, then we cannot sell or explain the improvements or understand what is going on. And finally, as said, the gate-to-gate approach will be of great importance, and we need to find the prioritization between reducing emissions, reducing noise, improving vertical or horizontal flight efficiency, and so on. Is this easy? No. Do we believe that we can manage? Yes. If we all support each other and if we go for it like we started already years ago. So I hope this is the good introduction, making you hot for the rest of the day. I wish you to enjoy the rest of this FABEC Environment Day.
Thank you very much, John. And we now move into the first of two presentations in a traditional format presentation. Then there's a question and answer session afterwards. So whilst the next speaker is speaking, do think about those questions that you can ask either here in the room or at home via Slido as well. The next speaker is the COO of Skies in Belgium, and she's also the chair of the Standing Committee Operations. Peggy de Vestel, the floor is yours.
Thank you. Good morning, everybody. The aim of my presentation is to give you a small introduction or a small explanation about the vertical perspective. I'm trying not to do it too technical because I would like to explain you how we are going to achieve this on FABEC level. Does it work? It does not work.
We'll be with you in just a moment.
Okay, sorry for this delay. So the content of my presentation is, first of all, the key challenges that I would like to explain to all of you, and how is an ANSP, air navigation service provider, enabling the airspace users to reduce the emissions. First of all, I think operational procedures are quite important, and also what you are going to do with our future developments. What is also a very important question is what is the impact of climate change for an ANSP and aviation? And of course, I will give you some conclusions on this. I think it's very important for setting the scene. As John already explained to you, we have the roadmap Destination 2050, where we would like to go towards a net zero CO2 emission. It has been a joint effort between the airlines, ANSPs, and also manufacturers, and they published this report in February 2021. And some things are quite important to highlight. It's composed of 4 important pillars. First of all, you have the 37% of the improvement can be done by aircraft and engine technology. Then we have 34% for sustainable aviation fuels. Then you have 8% of economic measures, and then you have the 6% of the improvements in the field of ATM. So we could reduce also CO2 emissions from our part. What is quite important to highlight is ATM is not only ANSPs, but it's also together with airlines. So we have to work together, and it's a shared responsibility, and of course ANSPs has to play a very important role in this. What we saw is that especially in the phase of climb and descent, these are the phases which can give a big improvement on the emission of CO2. But some things has to be clarified. What we see is nobody really knows how to measure this impact. And I think it's very important to mention this. And what is also important that the vertical movements, especially close to the airports, are also dependent on the complexity of the airport and the congestion level around the airport. And FABEC, we have implemented several procedures to improve and to enable to fly environmental friendly flight paths. There should be a trade-off between noise and gas emission. So when you look around congested areas below, it is important to say that the discussion cannot only be limited about the CO2 emission. Close to the airport, noise plays also a very dominant role, meaning that the limitation of the noise emissions has priority. On the other hand, if you look to the cruising level, gas emissions are also dominant, but they cannot limit to CO2. And Ilona, my colleague, will explain this afternoon a little bit more because there are also non-CO2 emissions which are important for the environmental footprint. So we had to make a trade-off between noise and gas emission. I think it's also very important because we see closer to the airport, the noise is also a very impacting role. And then, of course, you have the dilemma of the noise. We introduced PBN approaches, which are satellite navigated approaches, which gives us a more precise flight path towards the airports. But on the other hand, it means that you have much more concentration over one stream towards the airports. That's also a trade-off that we have to do. Or we spread the noise overhead more bigger population, or we concentrate, but we also raise the amount of flights more on a narrow path. This is, of course, a political decision, and it's not an operational one. And what is also important that due to the PBN, we have also a higher number of accuracy and also a higher number of capacity towards the airport. What is our role as an ANSP? It's safely enabling environmentally friendly flights. I think it's very important to say that because safety is our top priority still for an ANSP in the aviation world. You can compare it with roads on the street. So the farther you are from a big, busy city, the less traffic jam you have. The closer you go, the more traffic jam you have. So you can compare it in the air as well. So we as an ANSP, we provide an infrastructure to enable the airspace users to fly based on their needs while ensuring safety, which is also very important. But also what is happening closer to the airports, you have more dense traffic, and there it's quite difficult to manage the environmental footprint in a correct way. On the other hand, you have aircraft operators who are planning their flights. We are offering a kind of an infrastructure, but it's also important that the airlines are using this. So because they're choosing their routing based on cost, on environmental aspect, and also on internal routes or company policy. And of course, the closer they come to the airport, then it is an interaction between pilots and air traffic controllers to have an optimal flight path towards the airports. So when we talk about the operational procedure, one of the things is continuous climb. And what is the environmental objective? Is to reduce the fuel burn and emission of avoiding leveling. What we see in FABEC, we have almost an optimal use. So when you look to the picture, the green lines are really the continuous climb operations, it's called CCOs, where we have almost so we have to make a distinction between the CCO fuel and the CCO noise. Why do we do this? Because especially the noise is coming from 1,800 feet to flight level 75. There we see that 96% of the flights are already performing a continuous climb. The other share of the CCO fuel, which is from 1,800 feet till the top of climb, there we have 76%. It depends also on the standard departure routing, also on the weather conditions. Sometimes traffic has to level off because of a thunderstorm, or they have to avoid also other aircraft. So therefore, the closer to the airport, the optimal use of CCO towards the airport. Then we go to the continuous descent. It calls the green flights. So what it is also important that is we have to avoid the level off. Once an airplane is staying at the level more than 20 seconds, it means he does not perform a CDO. So when we see, we have also different definitions of CDO. Sometimes it is a CDO from top of descent, sometimes it is from 105, flight level 105, sometimes from 75. So this is something very important that we had to have a very common definition on what is CDO. What is also happening, airlines are also using other figures of CDO. So we have to understand each other and to have a consistency on the definition of CDO. And as I said, it's also important about the congestions around the airport and about the complexity. When you look to the FABEC airports, here we see that we have already a lot of airports who are performing CDO operations. When we look then to the figures of CDO fuel, so as I said, top of descent to 1,800 feet, because at that time they are intercepting the ILS, we have 19.9%. When you look to the share of CCO noise, there it's a little bit higher because we are working on a lower level between flight level 75 till 1,800 feet. There we have 37.6%. And I must say the implementation of these new CDOs was already a target for the first FABEC performance plan, which started in 2012. And this is also a very interesting graph. What you see on the top, it is the CCO, so the continuous climb operations, where you see that we have between the 70 and even to the 90% of efficiency of flight efficiency during this period. When we look to the CDO, it's lower. But there you can see the graph in 2020. That's when the pandemic started. And there is a link between the amount of traffic and the possibility to fly CDO or CCO. So the more traffic, the more complexity, the less possibility that we have to fly CDOs. So this is, I think, a very important, and this is also a trade-off that we have to know. Or you have an environmental benefit, but then you have less traffic, or the other way around. Another operational procedure is XMAN, Extended Arrival Management. What does it mean? So in the beginning, most of the important airports installed AMAN, Arrival Management. This was in a range of 80 nautical miles, where a system instructed towards the air traffic controllers whether the flight should reduce, should take another level, to avoid a kind of holdings, so if they have to turn around the aircraft, is also a lot of fuel burn. So we introduced already AMAN. The XMAN is something additional. So it means in a range of 200 nautical miles already, there is already an instruction where we can say to the pilots they have to reduce to avoid extra fuel burn or to avoid extra track mass to fly. This, of course, as we are in the center of Europe, we only can do it when we have close collaboration with other ANSPs. So this means that if you like a flight from Frankfurt to Brussels, this is if we implement an X-Man at that time, it means that we can improve the collaboration between the different ANSPs, and it's not only ANSP related. So the cross-border and the cross-ANSP cooperation is really necessary to improve that. If you look to the airport of the X-Man procedures, there you see we have already very major airports who implemented the X-Man procedure. We are still ongoing. We started in 2017 with the implementation of X-Man, and we're still working on it. So we have DSNA. It's a flight between Heathrow, Barcelona, Paris. MUAC also introduced SkyGuide, Italy, with Italy, Rennes, and Paris. Due to the COVID situation, there are some small delays on the one in DFS Skies and LVNL, but we are still on track. We will run up later on. What is also important, as John already mentioned, we won in 2019 the X-Stream, which is a sub-project from the X-Man, and it is especially concentrated around Paris-Charles de Gaulle. What is the environmental contribution on this? So if we implement the full X-Man project, we will have a fuel saving between 94,000 tonnes and 29,000 tonnes. Why is there such a difference? Of course, the more traffic there is, the less possibility to have the benefits. And if you look to the CO2 emissions, it's just the same. So it can vary it per year between 296,000 and 912,000 tonnes of CO2 emission. So X-Man has a potential benefit for the industry. We also see there is a lot of changes of climate around the airports. So what we see is that we see the last years a lot of local aspects around the airports. We see changing of the wind, probably because of the climate change. We also see heavy rain. We see it last year that it evaluates much more than before. So we see an impact on the climate. Just to give you an example, if you have the run we use, it's in one of the major airports in FABEC. Mainly we have the flights going westbound because of the wind, and then we see suddenly in 2018, it was almost 50-50 where we used the eastbound and the westbound for the same time. It's quite strange because normally the westbound is the dominant direction of the flight. It is maybe too early to make conclusions on this, but we see also when we do the study with other airports, we see that the other direction, the easterly bound, is very much more in favor than before. So this is also one of the aspects that we have to count on, because also as the operations are mainly designed for the main direction of the airport or the direction of the departures, there we have to look how we are going to adapt the procedure for the near future. Maybe one of the good things is that we have less snow the last years, because probably of the warming of the earth. So this means also less ATM delay, because we have less snow conditions in FABEC, so because of this. So what are the main conclusions? So we, ANSPs of FABEC, we are contributing to reduce environmental impact by aviation. We're giving the infrastructure, and we have to work closely together with the airlines to improve this kind of operations. But however, there are trade-offs. As I explained to you, the more traffic, the less possibility to have an environmental benefit, but there we have to find a balance between the two of them. And of course, it is on political level that has been discussed. And what also important is climate change leads to an effect on the aviation, especially on the increase of emission. So we are committed to support the airspace users to reduce the aircraft emission. And also we have to work closely together with the airlines. This is the only solution that we found, because we can offer a lot of things, but the airliners have to take those opportunities. And of course, as I said, there are some trade-offs to discuss. And of course, we will need some compromises. Thank you very much.
Thank you, Peggy. You mentioned the X stream as well. I think one of the things that I particularly like about that is the fact that it's not possible just with an ANSP doing something. It's not possible just with the airlines doing something. It only was possible with everybody in the game, the airports, the airlines, and the ANSPs working together. And so I kind of also see a lovely role model example of how we can work in the future there too. You showed us some pictures of the continuous descent operations, the continuous climb operations, and there were some pretty big differentials there. What are they down to? Why the big differences between the CDOs and CCOs?
Well, it's quite easy to explain. When you have a CCO, so once the aircraft take off, at the end, they go with a kind of dispersion towards all the directions. So it is easier to give this continuous climb profile to the aircraft. But when you go to the CDOs, then it's also limited to the runway capacity of an airport. So it means it comes from all directions, and it all has to canalize to one direction. So, and at the end, you have vertical limitations because you have other aircrafts, you have to level off. It is quite complex, so it's easier, the performance are better with a CCO than a CDO due to complexity. And of course, FABEC is one of the most complex airspaces, so it's a big challenge for us to improve the CDOs for flights.
What would it take, though, then to improve those CDOs? Because presumably simply saying, emptying the skies of all of the other aircraft is one way that you could do it, but it's not a very useful way to do it. What else could we do?
I think also the flexible use of airspace, the complexity of the airspace is one of the limiting factors for this. So we could use the optimized module of an airspace. I think it's quite important. So, and also to work together with the military. So, because if we have a flexible use of airspace with the military colleagues, then we optimal use that airspace as well. So we can easily make more CDO approaches towards the airports.
And you mentioned that that there are different definitions of CDOs, of course, which leads us immediately to not being able to compare apples with apples. Why do we not just have one definition? Because it seems to me, if we're thinking purely environmentally, then surely the right thing to measure is top of descent to 1,800 feet or even to runway threshold. Why would we not go for one definition everywhere?
This is also something that we have to discuss, of course, because sometimes we had a lot of discussion, what do we understand with CDOs? And if we have one clear definition that the airlines can use, that the ANSP can use, it should be much easier, so because we can measure it correctly. We still have the discussion, like for an ANSP, we have good CDOs, but for the airlines, they are not happy with the CDOs. So it has to be clarified what is the definition of the CDO. And
in how far do you think that the definition should come from, I don't know, somewhere like EASA or even ICAO to make it a global thing? And in how far should it come from the airspace users themselves? Because, of course, the continuous descent operations is something that the users are interested in too, A, for the fuel burn aspects, and B, to fulfill their own obligations in terms of the environment.
That's a quite difficult question, of course, but I think that airlines and ANSPs are well positioned to understand what is a CDO. So what I think we should sit together around the table and define the clear definition so that everybody is happy with that kind of definition.
And a definition that spreads how far? Is that a definition that's good for FABEC, or a definition that's good for each state, a definition that's good for Europe, or do we actually really need a global definition, in fact?
In fact, I think for Europe it should be already a big achievement to have a global definition. Yes.
It's well known that all the European states always agree on things like this. Talking about that, though, do we not have the same challenge when we look at the noise, both the noise distribution dilemma that you talked about, but also the noise versus emissions dilemma that we have? Because in different countries, the altitude or the height at which we switch from giving primacy to noise to emissions varies as well. So that's not the same everywhere. Does that not, again, make no sense? Because surely there are the emissions elements are going to be the same everywhere else. Is noise sensitivity something that's local?
It is especially local. For my personal opinion, it's also a political decision that you have to take. So, but I think it's the noise emission is something that is directly contributed towards the people around the airport. So I think you also have to give a kind of a definition to this as well. So to understand, because sometimes we have a lot of discussion, and what is noise? So there you have to also define a framework for this.
And do you think that that's something which it would be beneficial to do at a European level, or is it actually best just left to each individual state to deal with?
I'm convinced we have to do it on the European level.
Okay. Thank you. I'm going to stop my set of questions at the moment. I've got loads more, by the way, Peggy, but I'd just like to offer the opportunity, first of all, into the room here for anybody who's got a question, and then we'll go to Slido after that. There is a roving microphone. Eric, there's a microphone on its way. Not because I can't hear you and Peggy can't hear you, but for the people at home.
Someone has to break the ice. Huh?
Absolutely.
Could you imagine that you could solve the descent profile with an X-man or something like this? Because the problem is not the quality of the ANSP of the airline. The problem is only the number of aircraft coming in this time, and every movement that we make with an aircraft is not necessary generate emission, CO2, and noise. And the only things that we have to do is to manage it and not control it, so that the number of aircraft are according to the runway capacity.
Well, this is quite a difficult question because, of course, it's a trade-off between capacity and a trade-off between environment. I'm convinced with an X-man procedure that if we know in advance what kind of speed that an aircraft has, because airspace has a big dimension, sometimes it's not optimal used. So if we more optimal used the airspace by an X-man, I'm convinced that the reduction of like leveling off or giving more speed can reduce the emission if you say from advance, so 45 minutes before they get into the airport, if you can give an instruction what is the speed that they have to fly. So it's a trade-off that we have to do, of course. Aircraft are there. It's a business. It's also, aviation is important for the industry, so we cannot neglect this as well.
Good. Geoffroy, whom I'm going to call Jeffrey from now on, by the way, just to make it easier for the English speakers, and then I'll come to Régola. If you would be kind enough, Céline will...
Yes, good morning, everyone. Let's not forget one important partner in this discussion. It's the communities. Because when you talk about noise especially, they have to buy in what we're saying. So we can come up with a perfect engineered definition that makes sense for us. If it's not accepted by the communities, they will reject it. And the CCO for them is really noise-oriented. They don't care about CO2 versus the noise. Generally, it's really the noise that is important. So if you target the noise for the last part of the CDO, then we'll be very pleased. I can give you an examples around Charles de Gaulle, where we had the big fights like this, and we designed CDOs during the night, but we were doing only 4 or 5 per night. And suddenly we switched to the definition used by NATS around Heathrow, and suddenly we were doing 53% of CDOs from one day to the next. But they applauded because it was the right thing to do for them. So we have to trigger this relationship and this constructive view of what it is all about. So it's not only about ATC and the airlines or the airport, it's also the communities. Let's not forget that.
Thanks very much indeed, Geoffrey. And we will hear a little bit more about the specific example of Schiphol, no doubt, this afternoon in the panel session as well, which has had to deal with that for quite a long time. Speaking as an ex-Heathrow approach air traffic controller, I know that we tried to do CDOs, and we tried to do CDOs, but only from 7,000 feet. Because, of course, why? Because above 7,000 feet, we had horrendous holding inbound pretty much all the time when it was busy. So you couldn't do anything, and you certainly couldn't construct something that looked good above 7,000 feet. But the trouble is, that isn't good enough. That isn't good enough for us, and or indeed for the environment today. So we do have to think differently and think about those X-Man elements that that Peggy was talking about as well. The other question that I'm interested in, to just sort of follow on from Geoffrey there, is I wonder in how far some of the trade-offs might change over time. So today, for the sake of argument, we say below 7,000 feet above ground, it's noise has primacy, and above 7,000 feet above the ground, it's emissions that have primacy. But how many thousands of tons of fuel or emissions is it okay to produce to give that primacy? And will that one day change? Because one day we'll say, no, the CO2 emissions mean that we have to change that, and now it's only 5,000 feet noise or something like that, just simply because we will evolve as societies and the communities will see different things as being important. We'll maybe touch on that a little bit again this afternoon. Regula, may I give you the word?
Thank you very much. Thank you very much for this speech. A couple of thoughts and comments, maybe more from the PRB point of view. Those who don't know me, I'm Regula Detlingot. I'm the chair of the performance review body of the Single European Sky. And thank you for having this event because it's needed that we have, and finally in person again, a discussion. The PRB has monitored very closely what has happened in 2020 with the low traffic. And I think there are very many learnings, and especially in FABEC, because FABEC has most of the traffic in Europe, but it has also the problem zones, if I may say so. When we had 2019, we knew where the hotspots were. And so I think there is such an opportunity to do a lot of learnings in low traffic scenarios. And the challenge now will come back when we have higher capacity again or higher traffic. The network manager has said, all in all, there were even 1,500 restrictions removed in the CES area. So now the challenge comes, of course, what do we do with these removed restrictions? Can we keep that? And I think that whatever FABEC can be as almost the light beam of giving an example, that would be great. One thing that we have also seen is that in terminal area, actually the improvement was higher than in terms also of environmental efficiency than in en route. So the airports did a bigger job during the low traffic scenario than en route. That was a surprise to us. Flexible use of airspace. We have done a study in the PRB, and the learning is there again, a bit of a surprise. The impact was much less than always, or many said. And it's concentrated on 3 or 4 hotspots, and one of them is within FABEC, Germany. But altogether, the impact we can expect from flexible use of airspace is less than one would think. Because, and of course, we don't have enough data yet. What happens if the military releases the airspace? How well is it picked up by airspace users? There is room for improvement, and we hope we get better data to see how well and where is it picked up the best. Now, trade-offs. One last remark. I don't want to pick up too much of your time. It's trade-off, yes, noise and CO2 emissions, but of course, now in the next 2 years, it's also about money. That for airlines, it's a matter of survival now. And I think there we have to be realistic. Of course, from an environmental point of view, there are many. The best flight in CO2 terms is the one that even doesn't take place, to be a bit cynical. But of course, we can do better than that, and we have to do better. And I think to find the balance will be a real challenge. And again, I'm looking forward to the further discussions.
Thank you very much indeed, Regula. And we have in the room both a current chair of the PRB, a former member of the PRB, and members of the Performance Review Commissions as well. We'll talk to one of those this afternoon too. A lot for us to think about there, Regula, and there are certain things which are going to be very interesting in the coming times. But one of the relatively clear-cut pieces is that we don't know enough yet. We don't have enough data. We're pretty sure that we don't have the right metrics. But what are the right metrics? And we go through with that, and we'll touch on that in the panel session very specifically this afternoon as well. Another sort of thought experiment that we did in Skyguide just recently was to say, let's think about this analogous to the way we think about safety. If you have an airspace with no aircraft in it, it's a safe airspace. Must be. If you have an aircraft with one aircraft in it, you're going to be able to fly your environmentally optimum route. Now, that environmentally optimum route might not be the one that the airline then chooses to fly, for the reasons that Regula's just said, but at least we can think, okay, so we know what that environmentally optimum route would look like. Then, what is it that stops us flying those environmentally optimum routes? So it might be the military, but how much does that make as a difference? It might be the fact that we've got too many other aircraft in that airspace. So therefore, the answer to that would be provide more capacity. And then at some point, you get to again, we're back at the political level. If you keep adding capacity and keep adding capacity and keep adding capacity, you're then criticized for attracting more aircraft into the airspace in the same way that the motorways get fuller if you add more lanes. And that's then politically unattractive at some later stage again as well. So just a thought experiment in that direction throws up one or two things that are definitely clearly good to do. And that's to deliver the optimum amount of capacity needed by the system. But the second or third thing that becomes very rapidly apparent is no one state, no one ANSP, no one tiny little local region can sort this for themselves, because the problem, let's pick Switzerland, we're in Switzerland. The problem is not created by the aircraft going from A to B and then doing a dog leg like that through Switzerland. The problem is the aircraft should actually be over here and not there in the first place when it enters the airspace. So it becomes, therefore, certainly a regional element, and we're back to network management and elements like that as well. Rob, I see you've got the microphone.
Absolutely, and I won't give it back for the next 12 minutes. No, thank you. Good morning, everybody. My name is Rob Peters. I'm representing the FABEC State Bureau, although I'm on the payroll of Eurocontrol, but you can trust me, I'm a nice guy. I have two questions, and one is more a supposition, perhaps. I think in Peggy's presentation, there was quite an essential message that stated that the lower the traffic, let's say the bigger the effect of CCO and CDO will be, which is logic, I assume. But having said that, I'm always wondering whether or not ATM, as a 6% contributor to possible CO2 reduction, would have the balls to communicate externally to provoke, let's say, the lowering of traffic. This is the moment post-COVID, let's say, having witnessed the effects of minimum aviation vis-a-vis the environment. I mean, are we courageous enough now to step on stage and communicate in whatever kind of event that basically this is the moment to opt for less aircraft movements as from now on for the next, I don't know how many years, question. The second one is the, what I never understand, and I was turning to, I prefer to call him Geoffroy, as the former chair of the Standing Committee Ops, there's always this everlasting returning statement about the absence of a CDO definition, which I don't understand. I mean, there is an ICAO definition, definitely, there's an ICAO manual. There have been many task forces, and I've been just checking my files, but I think one of the more known was the CCO-CEO task force, already established in 2015, the Eurocontrol task force, where all the stakeholders agreed on the definitions and the implementation guidance. Why do we still, almost in every environmental presentation, keep coming back to the absence of a CDO definition? I really don't understand it. Thanks.
Thank you. Rob, do you want to respond to either of those two elements, Peggy?
Well, as I said about the definition, Rob, there are different definitions about CDO and especially CDO. As I told, you're talking about CDO fuel, CDO noise. Sometimes it's coming from flight level 105, some of top of descent. So I know there were a lot of discussions, but at the end we have to make a conclusion on this. And it's also, what we experience is also the airlines are using other definitions, which is logic because they have their own targets. But therefore, I fully understand what you said, but at the end we have to come to the final definition, and that we don't have it yet. Who
needs to do what? This is actually a general question, I think more to the room than anything else. Who needs to do what in order to nail down a definition, at least in Europe, that we can use? Regular?
Performance and charging regulation, of course, in an annex you could do that.
So we could do that via the performance and charging regulation in an annex, yeah?
So any member states can come up in the next Single Sky Committee and bring forward the definition. How about
Okay, so that's a possible way forward there. I'm going to look to you, Marcel, even though you personally, of course, but if we can work to produce something that is usable, or at least as a straw man for a European-wide definition, then why don't we do that? That would be, a decent outcome of this conversation, if nothing else is. So we'll take that. And your first question, Rob, is also a very interesting one. Is that not a states question? Is that not a question to the states, though? It would be unorthodox, I think, for an ANSP to say to its customers, we think you should be flying less, because at the same time, of course, we get less money, which means immediately it's a problem for the owner of the ANSP.
I don't have a microphone, but I'm still able to reply, I think. It's a yes and no, Alex. I mean, we have a common responsibility, at least that's how we are trying to promote our environmental responsibility. So, yes. Yes, you are sort of right. In the same time, I completely disagree with you. I think we have a common responsibility. I never thought I would say this one day as a former controller, trying to speak, I think, greenish, I would say. But I think this is the opportunity. So it's a little bit of un pour tous, tous pour un, I would say.
Okay, thank you. I'm going to switch to a question from Slido before we go to Mark. And there's a very interesting one about X-Man that's come in here, which the basics of it says X-Man, of course, goes across the national boundaries. It must do in order to work. And so how do we go about dealing with the situation that an ANSP is then required to manage 3, 4, or 5 different X-Man priorities for different ANSPs around? How do we go about prioritizing between those?
Of course, now we have an implementation roadmap where we implement step by step. And indeed, it is a big challenge at the end how we are going to manage this. Right now, we are not there yet. So we have specified the roadmap where we introduce expand that airport, which are far away from each other. But at the end, we have to see it overall, how we are going to manage it. This is still something, it is first of all experience, it's also air traffic controllers have to train on this, it's a quite important issue, but we still have to do that.
Is there a role for FABEC in that, or is that, again, something more better done locally, Or is that something that you think, for example, you specifically as the chair of the Standing Committee Ops, you can take a role in?
I'm convinced that we have to work together. As a single ANSP, we never will manage this all alone. And of course, yes, I'm in favor for, as Standing Committee Operations, I'm in favor to coordinate this internally within FABEC. That's indeed, yeah.
Very good, thank you. Mark.
Thank you very much. Peggy, thank you very much for this very clear presentation. I have a question, and I hope I will be able to allude to that this afternoon again. The 6% you have explained that ATM could contribute and things like this, how do you see that? So if we all work together wonderfully and everybody is singing the same tune, how far will we get to zero?
Well, of course, the 6% is the results of the roadmap Destination 2050. And it's been created by the airlines, ANSPs, manufacturers. It's also been supported by the Technical University of Delft and Amsterdam. You can say it's only 6%, but it is 6%. So all little pieces will help. How we are going to do that? Well, I explained you by, this is a part of the presentation. I have my colleague Wolfram who also will explain all those little pieces like CDO, CCO, X-Man. We will have the free route. We have the dynamic red, which Wolfram will, I'm not going to explain his presentation. But all those little pieces, there we will reach the 6%. It is very, let's say it, optimistic, but I'm sure if we're going to work together, we will reach that 6%.
Very good. And we've got one more. There's a comment, so thank you to those online. That of course there is a CDO CCO task force which came up with a definition. So we'll start with that and then have a look at that together. And that's certainly something we'll bring up to the ANSCB, which is the state's meetings with the navigation service providers. That's on Wednesday, in fact, this week. So that's something very concrete that we can take with us as well. In the absence of any other questions, Peggy, I thank you very much indeed. Thanks for your inputs and for your presentation and for answering the various questions. And let you go and sit down, and we'll welcome the next presenter in a second. Thank you, Peggy. And that was the terminal perspective. In other words, ground to a small number of thousands of feet. And for the next presentation, we'll go a little bit further up and look at the en route perspective. And for that, we have Wolfgang Brettel, who is the head of the ACC in Munich, DFS therefore. And he's also, very relevantly for this, the head of ACC's group, if you see what I mean. And he chairs the head of ACC's group as well. Wolfgang.
Yeah, thank you very much, Alex. Thanks to the audience for being here, and thanks to the people on the video. It's a great pleasure to have faces again, not only faces on a TV monitor. And it just mentioned I'm now in Munich, head of the ACC or director of the operations in Munich, as not only the ACC belongs to it, as well the approach in the tower control. And as a former controller as well in the upper airspace and in the tower business, it's really interesting to listen to these discussions. And I want to contribute with my presentation about now the horizontal part. Peggy made in and outbounds, and now we come more to the horizontal part and how this contributes to in environmental issues. Well, my presentation is the same kind as Peggy's. I'll talk about some key challenges and then about some operational procedures we have in the en route part. And then as well, coming at the end to some impacts of the climate change. And my conclusions are, no wonder, are some of the same kind of like the ones from Peggy. So well, first, key challenge is what can we do better en route? Well, on the horizontal flight efficiency, we must admit we are already close to the optimum. We see here the 97 in green on the left, which shows that the use of direct routes is nearly to the optimum, and we can see that during the pandemic, even at that time when we had quite less traffic, it was only a few minor improvements possible. So here, a good statement is that we are already very, very good in the en route phase, and further improvements are always limited to weather impacts, for example. Weather impacts are not plannable, at least not in a sector or in an ACC. We know that bad weather is coming. This morning I heard in Germany we will have bad weather on Thursday, but we do not know where exactly. And this is very important for us to know, is it over the airport of München, or is it over the airport of Geneva, or is it over the airport of Nuremberg? And of course, some security needs have to be respected as well. When we talk about direct routes, we all know the situation in Belarus, for example, or in the Ukraine, and out of a sudden we cannot use direct routings or best routings because of these situations. And whenever we talk, just as an explanation about horizontal flight efficiency, this does not include the terminal traffic, which we say it's 40 miles around the airport. So we start to measure when we are outside of this area. This topic has just been raised in the discussion before. It's a very interesting one: flexibility versus stability. If you talk about flexibility, for direct routings, for example, we see that in 2020 we had additional saved 68 million kilometers and a lot of CO2, 1.4 million tons. And how is that done? It's done, of course, when the airspace users, together with the network manager, planning the flight routes, and the air traffic controllers then, on the other hand, give direct routings when the flight is in progress. So that led to this great number, and that is flexibility. You all know the situation when you are in a restaurant, in a good restaurant. You want to have the flexibility of this restaurant. You want to have your meat well done or medium rare, and that is a good sign for good flexibility. Is then when somebody takes time for you. The stability, on the other side, can be granted by standards. Staying in the terms of restaurants, you go to a McDonald's restaurant or Burger King. They have a great stability. They have a great capacity. Why? They have standards, and they can produce 100 meals in an hour. The good restaurant only maybe 20 or 40. Much higher price maybe. Both models are working, and in air traffic control we can have the standards, and we have the standards, and we need the standards in high traffic peaks, and as well now in the time when Eurocontrol stated, our network manager said altogether now 2.0. When we return back to normal traffic, how can we give our controllers the ability to stay safe when the traffic, which was down for so many months, is now coming back and returning, and how can they work in a safe way? And this is done by standards. But standards, on the other side, mean that you lose the flexibility and the benefits of that. Another key challenge, of course, is the airspace. If you look outside, you normally don't see too many aircraft at the same time. Of course, if you are close to an airport, then maybe more. But if you're somewhere in the area, you don't see so many aircraft, and you would say, well, there is enough airspace available for all these flights. Right, you are on the one hand, but on the other side, airspace is limited because if you look on this picture, we have 4 pillars which try to balance this line in the middle. One of these is, of course, the airspace is a common asset for civil and military. So we cannot just do what we want on both sides. We have an airspace here in Europe, and especially in FABEC area, with a very high traffic volume. We have the major airports of Europe in our and close to our area, which are Amsterdam, which are Paris, which are London, Heathrow, which are Frankfurt. Of course, Munich was, at least before the pandemic crisis, one of the major airports in Europe. And of course, we have several military airspaces, which with their needs to be used. And what we have to balance as air traffic control, as ANSP, is, of course, and this is all the time, and Peggy stated this that the same way, and I would do it the same, and every air traffic controller in this room would ever agree to that. First priority, safety. Nothing else to say about that. But then, of course, we have to ensure the connectivity of airports in our FABEC, in our European area. We have as well to ensure the military missions. They are customers as well, from my point of view, and I have to guarantee them the same importance. Then we have to find the trade-offs between capacity and environmental needs. And the regulator just mentioned that, of course, the financial needs, at least in the next 1 or 2 or 3 years for the airlines, and external circumstances have to be balanced, like weather or reroutings due to political tensions and so on. Another key challenge for us, of course, is the decision-making. We see that we have at least 3 perspectives where decisions are made in the context of air traffic management. Of course, we have a network perspective, and this perspective is very important because it helps us, especially in times of 2018 or 19, when we had such a lot of traffic and we needed to shift the traffic so that it can be worked with less delays, the so-called E&M measures in 2018 and 19, or the network operations plan. But it's not only the whole network perspective which allows us to improve our services as well, and that's me speaking now for an ACC. We have the internal agreements between several ACCs, because as well, the FABEC perspective is not the only one, because every area has a border, and then you have to deal with your neighbor. For me, speaking from Munich, in FABEC terms, I'm at the very east. I have more neighborhood with Austria than with Brest, for example. So the FABEC border is not the one which is the only one. We have to look for ACCs and how can we improve on both sides, and that is done, for example, with letter of agreements. And then finally, we have a local perspective. This is done operationally in the ACCs then, or at the approaches or in the towers. How many people are there, for example? How is there a sickness leave wave, something like that? So we have to take care for all these perspectives when we talk about decision making. Okay, coming now to the operational procedures. I start with the free route airspace. Free route airspace, I think, is known to you. In the past, we had only airways in the sky, which had to be followed, with a lot of areas of militaries. And then we decided further on to come to bigger areas with a free route concept in. But still, we have in this free route concept on the right, you see that areas which have to be taken into consideration. In FABEC, what we are going to do is on free route, we already have implemented free route airspaces, especially here in, you see that on the left, Maastricht and Karlsruhe is here about to do, and then we plan for the end of this year to improve it on the France side with parts of Brest and Bordeaux, and later on in next year, 22, we have as well in Switzerland the free route airspace, and the plans are going further. We want to integrate more parts of France, and finally, which has to be decided by the end of this year, what will we do with Marseille and the Reims area in France. But I think it's a good picture to see. You need a gradual, you need steps to do. You cannot say, okay, we do free route airspace all of a sudden in whole FABEC. that would never work. And with aims like that, too high aims, you would then just create a chaos. So these gradual steps are very well done. And finally, as I said before, it's not ending at the borders of the FABEC. It's as well with other FABs where we have to deal. And for example, you see the blue arrows. These are things we're doing with Austria, for example, or with Barcelona, to have a free route or cross-border free route to improve the situations then there as well. And so out of these little tiny steps, we can create a free route airspace all over Europe. The benefits of the free route airspace, we had a simulation in 2019 which said 200 million of euros fuel burn has been saved. Here we must state that these data are outdated because we have a complete different traffic mix now. The route structure had improved, and of course the civil and military cooperation is improved. We don't see the impact of the pandemic and the volatile traffic streams yet, and so we are doing some new studies. But of course, this free route airspace is about to save another few fuel burned and CO2 emissions. So, flexible use of airspace, we talked about this as well before, and here you see in the graphs what it really can be. In the top line, you always see there is a red area. This is used and full stop. And then you have to fly around. You can fly around via the left side or the right side. That is your choice, but you cannot choose to go through that area. And here we come to better solutions. For example, segregate this airspace in here in this example 2 parts, and say that you can use the right side, which is green for that time the flight is coming, or in the second example, you have a vertical split, and so you can use the top of the area. And finally, if the area is planned and booked but not used, why not use it from the civil side? And this is flexible use of airspace. I'm pretty happy what we have in Germany on that. I know that in France is very, very good improvements on that. And that, I think, is the way forward. Here because, as I said before, airspace is a rare resource, and here we block it for maybe nothing. And if we talk together, if we cooperate, there is a good way to find this other pieces to improve. Another operational procedure I would like to talk about is the RAD, the Route Availability Document. It's you can compare it, and again something from the presentation before, you can compare it with roads, what we all know, and the RAD is something like the traffic signs we know all from the roads, and in areas where not too much traffic is, like on a highway, you don't have too many traffic signs, but when you come closer to areas where a lot of traffic is, like cities or around the cities, then you have a lot of traffic signs, and they are necessary to steer the traffic to certain directions. But we had a number of RAD measures in 2020 and 2021 lifted, and here we got an award for that, the ATM 2020 award, because at that time it wasn't necessary because there was not so much traffic, and we could release or lift some of this or many of these RAD measures. And but of course it can come to a situation that they come back, or that some of them come back, because we need that to guide the traffic to areas where we still have the possibility to fly. And you can compare it, for example, with the ENM measures we had in 2019, where we put a lot of traffic into the lower airspace, which was a burden for the airlines because they couldn't fly at a perfect altitude or level. But on the other side, they could fly. If they would have filed through the upper airspace, which was full, then there was no way. And with this science, with this RAD, we try to deal with that. Dynamic traffic management is as well something we have to work on. We have to improve. And this means, in short words, how can we reduce the time from flight planning to the flight itself? And the shorter you can make that, the more flexible you can be. This is a point of technology. We have to develop systems which can interact much better, and we can then produce finally a better situation in the environment. But as well, from the figure side, we have on the blue figure of 94 is the planning side of direct or most efficient routes, and the 96.7 or nearly 97% is the one when we have when we are really in the air and measure that. There is a trial in France on the dynamic traffic management. And in short words, that it means that we try to shorten the time from flight planning to really doing the flight. And when we do that well, we can improve as well from the slide before the planned flight routes towards a situation that they are nearly or close to an optimum. Okay, then some words about the climate thing. Well, first, a very operational thing from my ACC in Munich. You see here a situation on the slide that the red line is just the inbound stream we have from the south, so from Padua ACC, from Italy. This is the normal routing towards Munich Airport. And as you may know, the Alps, especially on the north side of the Alps in summer, we have a lot of thunderstorms. And this is a situation which happens very often during the summer, that they are coming in and this is blocked. Normally, one reaction is call the network manager and say, okay, please regulate this area and reduce the traffic. A different possibility is, of course, to fly around. And here we could see that, of course, there is way, but there are ACCs which are normally not affected by that flights. So if you circumnavigate via the east, you affect then the Vienna ACC and Karlsruhe ACC, and if you divert to the west, then of course it's Zurich ACC and again Karlsruhe. But we made some free areas instead of the one in the south where they can fly to. And maybe with some holdings at that areas, but we at least could guarantee that that we do not have to regulate the traffic that much down. It's a little detour, but on the other side, we still can guarantee that some flights are coming. Of course, in the last 16, 18 months, we didn't use that too much because that wasn't a big problem at that time. But now it's returning, and of course, we will take care again, and we will do that good. As well, impact on aviation is the climate change with one picture missing. Okay, we are working in FABEC, especially in the head of ACC group. We are really dealing with this impacts on aviation and how can we improve. What we would like to have is, of course, better forecasts. But knowing that that this is limited to a certain extent, we just heard this not this morning, 2 days ago. It was there was a meteorological guy asked, "Why can't you tell me where the thunderstorm is coming?" And he said, "Well, put a pot, yeah. Put a big pot on the oven and put water in, heat it up, and then say me where the first bubble comes up." You don't know where it's there, or there, and that's the same thing with thunderstorms. And of course, I think there is a limitation in prediction. So we have to understand that we, of course, even having the wish to know better where the thunderstorm exactly comes and moves to, we have to understand that it's limited, but still we can improve here with, for example, the procedures I presented before with Munich, or here in the lower left part, we have the area of Frankfurt, which is as they do it like we do with here with a weather forecast for the special areas and then the holdings there. Snow at the airports, Peggy mentioned that. The good thing on the climate change is we don't have too much snow, which is not a good thing at all. Being from Bavaria, I would like to have snow, but well, but we still have to improve that. And even if we cannot improve it totally, we can still try to make it better. And better predictions then can help us, and the coordination and the work between ACCs can be improved. Okay, coming to my conclusions. The horizontal flight efficiency is already very, very good. Of course, we can integrate the vertical part, the vertical dimension, to the overall picture. And of course, there is still work ongoing. We have to optimize the current system as good as we can, and we have to adapt to the new circumstances. The determining factor is the traffic load, of course, and in consequence, yeah, how to balance capacity and the environmental needs. And of course, in the next 1 or 2 or 3 years, the financial needs with respect to our mission, which is still safety first. And a way forward can be operationally, we need a better understanding of the climate change. What does it mean and what will come to us? And of course, the impact on the aviation system. Then we will continue with the work on operational projects like free route. We have to do that. We have to explore new common processes and tools to improve the flight plannings. And strategically, of course, the decisions are needed concerning trade-off between environmental and capacity objectives. And finally, and that is one very important statement, I think, here from Geneva, we have to intensify the cooperation of all aviation stakeholders. We need a good collaboration, a good cooperation among us. Then, of course, we can improve. Nobody, as Alex said before, is in the position to improve the system by his own or on his own without the others. And that, as soon as we understand that or understand it even better, then we will have a better system at all. So thank you very much for listening. And yeah, that was my presentation on the environmental part of the en route side.
Thank you, Wolfgang. Just picking up a couple of things, maybe from that last slide of yours. The impact of weather on the environmental performance, I think, is very interesting as well. Can you just tell us a little bit more about that? Elaborate on that a bit more. What is it you would like to see as well? What would help you?
Well, what would help us from an ACC or from air traffic controller's point of view is when is the weather coming? How severe will it be? And is only my sector affected, or is it in 2 or 3 or more other sectors? Is it a squall line or not? Which is very important. I don't know if you know that the squall line is a number of thunderstorms coming together and with no possibility to get through. And we saw detours, for example, when I was a controller, the hardest thing ever was a flight from Praha to Zurich or Geneva, and he was flying via the North Sea, so via Denmark, because of a squall line which was right over Germany. And if I would have known as a controller or supervisor that it will be a squall line, of course, then we would have the chance to react on that. Maybe reduce the traffic, but as well, for example, if you reduce the traffic and the squall line is not coming, a mess as well. So this is a very important thing. Snow at Munich or here Geneva, Zurich, we all know snow. The important thing is it much snow or is it only a few snow pits? And if you know that, or if you would know that, of course, then you can better react to it. And if you doesn't know it, then you of course have to spread your decision to a wider spectrum, and then of course it's different and not that precise. And maybe somebody's coming. I once was in the network management in Brussels when there was a regulation due to thunderstorm, and they said there is no thunderstorm. Yeah, but as a supervisor, for example, you don't know exactly is it coming or not. And if you don't know that exactly and you say, okay, safety first, I put a regulation on, then the thunderstorm isn't coming, everybody says, okay, stupid supervisor.
And presumably you could draw the same analogy with fog at an airport as well. The same thing. So what is it that's missing there? Is it technology? Is it modelling? Is it all of the knowledge that comes together, or is it simply scientifically impossible?
Well, I'm not quite sure what is possible from the scientific side. I think we are developing further, and maybe 30 years ago we weren't that good in predictions as we are today, and so I have the hope that we can improve in the future. But we have to accept to a certain extent that it's not possible to predict everything, and we have to be flexible in our reactions, what we can do. For example, with the thing I said from Munich, let's prepare for a situation when weather every year the weather comes. Maybe this year only 30 days, next year again 50 days. We don't know, but let's have a procedure in the back which could help us to be flexible when the situation is coming. Maybe you don't. The same with snow. In Hamburg, for example, you don't need too many snow trucks because there is snow once a year. But in Zurich, for example, it would be a mess if you would say, oh, well, one should be enough. And we can prepare like that and then live with the unpredictability.
And so there's something there about continuing to, on the part, not necessarily of the ANSPs, but on the part of the Met offices, of developing new techniques and using new tools. Do the Met offices always know what it is we need? Or is there something there as well about better collaboration with the Met office, not just the airlines and so on?
Maybe it's something about standards. We have different ways of working together with the Met offices in FABEC. We have in some ACCs there is a Met guy sitting in the office. We have others where they don't do that. We don't have standards when we look to a map indicating that a bad weather area is coming. Some painted in red, others painted in blue. So we don't have standards there. And the problem here is, for example, with the Met guy in an ops room. We have in Munich we have a special position assigned for that. But the people from the German weather service, they don't have enough staff to man this position. And well, it's happening only 10 times a year. So why should we invest money for this 10 times? But it would help if somebody is there to explain to a supervisor, well, this is like that, and it will most probably go in that direction. That would be better than having a supervisor looking on a screen say, well, okay, can go that or that direction, well, I put a regulation on.
Mm-hmm. Looking elsewhere on the last slide that you showed as well, you said something similar to John's mentioned it, Becky's mentioned it, and now you about decisions about trade-offs need to be made. And I mentioned it myself, actually, come to think of it. So we've had that, and I'm sure we'll have it again later on this afternoon too. Are we all sitting around waiting for somebody else to make these decisions, or who is it that should actually be making such decisions?
Well, if in big words, if politics is not taking the decision, well, we do things on our own. We have, for example, in Munich something we call ProMUG, which is a cooperation between the Lufthansa, the Airport of Munich, and the DFS. And we work on tiny little things to improve the system of the Munich airport. And we don't need a political decision for that, because we just know it's good. And we do it, and we improve step by step since 2004 when we started that. That is something I don't need the politics for. It's the clear common understanding of being in a business and being part of a business, which is, for me, for example, I'm not an airliner, I'm not an airport. I'm only ANSP, but I need the other people, because if I would say, the airliners, I don't care. well, it's ridiculous or stupid to think so. That is something to be understood. Be part of the system, and then take your partners and try to find better ways. That is something it's very important, and maybe the politics or a PRB or a PRC or the FABEC governance structure, they can help us, for example, like we had it before, give us a definition or help us to find a definition which then makes it easier for us to understand what the need of the community is. And then, of course, we go for that. If like the comparison with noise and CO2, well, I can do both from an ANSP point of view. I can take care for noise, then we make certain noise routes. I can take care for CO2 in the area of the airport. I'm hard to do both. So that is the guidance we need here. And environmental aspects are now more and more important. And from my personal point of view, having 2 children, I want to give them a planet too. So well, we have to look for that.
And so I'm picking up three things there. One was the link to the community that Jeffrey mentioned earlier on. And that link, presumably, in the example you gave, is provided by the airport authority, who are in touch with the community. The second thing I'm hearing is, well, we're doing this locally. We're taking the responsibility locally. We're not waiting for somebody else to tell us what to do. But then we're still missing something that says, let's bring it all together, because actually, presumably, someone else has got some best practices somewhere else that I might not know about. And it would be good if we could have some kind of guidelines that are applicable to all. Does FABEC have a role to play there, therefore?
Well, in your introduction, you mentioned that I'm the chairman of the head of ACC group, for example. And what we did is, it's not in the head of ACC group is all the 14 ACCs we have in FABEC are coming together 2 or 3 times a year, and we are exchanging on best practices. What is, I mentioned before, Munich and Brest is far away. But maybe in Brest there are some good ideas which I can pick up, or in Marseille or Bordeaux. And in this group, that is the main focus. A little bit on benchmark, of course, because why do you have more traffic in your sector, which is very similar to my sector? I have only, let's say, 42 and you have 45. Why? And then we try to understand, we discuss it, or sometimes a hard discussion, because you are not better than me, but of course you are. So what is wrong? What is going on here? And if you have a group like that, you start to understand, and if you like the people, then you discuss with them in a positive direction, and that is very important. And that is something FABEC gave us. Before it wasn't. We just had, of course, kind of meetings, but more or less with the neighbors. And here for example, for me, it was very exciting to see what is France doing, because from Munich point of view, I'm far away from that, and there are some good ideas there. And the other way around, of course, and that is something which is helping, or Luxembourg or Belgium or the Netherlands or the SkyGuide people, very important. SkyGuide, the system idea of having one system for both ACCs, great idea. And technically, which is not our discussion today, but it's an improvement to the system. Why not look at that?
Mm-hmm. Very good. So that also requires people to be to have a kind of an open mindset and to want to learn from each other as well. Okay, I think there's something else that we might be able to work on over time to say how else can FABEC help there, but there's probably a link to the terminal part too. It's obviously a en route and terminal join up at that point. Route availability document, the RAD. I saw that. And being in Switzerland, I know that we're one of the sort of the worst offenders of having a very complicated RAD. And of course, we've got a complicated route availability document in order to try and maximise the capacity available in that limited resource called airspace. And yes, loads of the restrictions could be removed for 2020 because the traffic wasn't there. When the traffic comes back, and here we come back, I think, to the same question from earlier on. When the traffic comes back, if we want to provide the capacity, then we're going to have to put some more restrictions back in. Or do we? Is there another solution?
Well, big question. If I would say yes, there is, and then you would ask, what is the solution?
I'm desperate to know myself, yeah.
Well, there is not one single solution for something like that. There are many little pieces which can improve the situation, and I think I like the comparison between the traffic on the road and the traffic in the air. If you come close to an airport, then the situation gets stuck, and you have to regulate it somehow. You have to get back to standards like you do on the road as well. But how can you maybe at least get this area around an airport maybe a little bit bigger, or a little bit smaller, where you have this hard restrictions? Well, technically, of course, there is something ongoing, like I mentioned, the system, the ATS system. We can find ways there. We can have better help from the systems. That is something which is very important to be improved, because that helps you to fill these gaps which are maybe still there. Well,
is it fair for me to assume as well that free route airspace will help?
Yeah, free route airspace from a controller's point of view. Well, when I was a young controller in the 90s in Karlsruhe, we had free route airspace. We didn't call it free route airspace, but whenever an aircraft was on the frequency, we said, "Guten Tag, identified, proceed direct to." So that is free route. That was flying direct, and you gave him the best level which was available. And of course, we are now saying, hey, no, don't give him the level he's requesting on the microphone, give him the level he's requesting in the flight plan, because with the flight plan, we take care that he's not affecting areas where are congestions. So free route, we need this what I showed here in order to give the give answers to the community. We are doing things, but from a very operational point of view, well, we had free route.
So you make a nice link to the last question before I open it up as well. So I was struck by the difference in efficiency between the flight planned and then the actual. So the actual flown was much more efficient than what was flight planned. And then you talked about reducing the amount of time flight plan to getting airborne, because actually, presumably, we can reduce that the planned inefficiency in that. How does one go about that, and how does one improve that yet further? Because we get to 97% or 96.7. Can we get to 98? Can we get to 99?
Well, it's very close to the optimum already. The difference between the two values maybe is that the flight plan is not only, from airline point of view, not only done with a look to the very best environmental flight plan, but is as well to the cheapest route, for example. So this is something that explains the difference between. And we have seen now during the pandemic, every flight was direct, even especially in the times when we had nearly no traffic. They were airborne and they got a direct to destination. And even in that times, we were not able to reach, for example, 99%. So I think there is a limit, and having 97, well, it's already very, very close to optimum, and maybe we can invest a lot of money, time, resources to improve to 97.5 or 97.7. On the other side, we have to take care what we take out of this. So is that really a question or a problem, or is it more or less to just improve it by just to improve it because we want to improve something? That is, I think, important.
So there you bring in another, if you like, another trade-off, which is to say the law of diminishing returns means that we could be spending our customers' money doing something, spending a lot of money, delivering very, very little benefit, in fact. So that comes back to the cost-benefit trade-off, that's a more classical trade-off, of course, as well. Question, I'm not, this one's for the room, or just to put it into the room anyway, it seems to me that in the next couple of years, the airlines are going to be even more sensitive to the whole package of their routing, and are therefore they're not necessarily going to fly or want to fly the environmentally perfect flight. They're going to want to fly the one that allows them to recover best, which is going to have the cost element that Regula mentioned earlier on. Is there going to come a day when the political instances then say, not acceptable to us, we do not accept that the airlines choosing to fly an extra X miles, which creates another 1% inefficiency, I'm making the numbers up, making an extra 1% inefficiency is not acceptable to us inside Europe. Nobody can answer that question, obviously. It's a rhetorical question, but it's again, interesting to see how things might develop over time. And I can picture that day appearing at some point, but hopefully the airlines will have been able to recover by the time we get there. May I offer the word to the room? Is there anybody who'd like to make a comment or ask a question of Wolfgang here? I'll go to John first and then come down to Regula. Do you want to just 2 seconds, just for the people at home or in the online?
Having been meteorologist in my past life, I have to react, of course, on what you say when you talk about the quality of the forecast. So I think the Met forecast improved a lot, but I think indeed there are several problems. I saw it also in Newark. First of all, the complexity of the airspace, and of course the aerodrome forecast or whatever. Your charts gives you a tendency and a probability about thunderstorms, but then you do not know the severity or maybe what are the tops. On top, in the past years, we saw that the systems are very stationary, so they stay on the same place. So, and then, but I hope that forecasts are good enough to foresee a squall line or isolated CBs. But I think, on the other hand, is also a problem also in the ops room. I saw also in Newark, and I don't say it negatively, there is sometimes also a difficulty for ops people to interpret the meteorological forecasts, and I think there we can both, the meteorologist and the users, improve. And I think, honestly, even if we didn't implement it neither in Newark, it really would make sense in bigger centers to have somebody working there who has more knowledge and on understanding and interpretation of the Met forecast. And then last but not least, you asked what should be improved. I think the timeline should be improved. So it does not make sense if I tell you nowcasting that you will have a big CP in 1 hour if you needed this information 6 hours before. I think there the forecast should also improve.
Thanks very much, John. I wonder. I know that some of the Met offices are in close contact with one another, but I don't know that everybody does. And I wonder whether there's a bit of best practice sharing that could be done at Met office level as well. Fairly self-evidently, there's a different set of challenges if you're in the southern part of Germany, in Switzerland, or in Austria, or in the Alpine areas of France, and the Met challenges there are quite different to on the western coast of France, for example. But it seems to me that maybe there is something about a closer cooperation there, probably also at the towers, because if we have conversations with people who know what they're talking about, with our operational people who know what they're listening to, we might be able to have a different type of planning as well. Céline, one for Regula as well, please.
Thank you very much. Just a couple of observations. It's interesting what happened with the FABs, isn't it? 10 years back, it was the evil of, first it was everything great, and then it said, no, FABs, we don't need that, and now it's a swing back, and the benefits of FABs is coming back, including the Court of Auditors said it's a very good platform, as you just described, and I think that is really something, it can be emphasized enough, a platform to learn from each other. Because if you look at productivity, throughput, and so forth from very similar sectors, and you see huge differences. Mm-hmm. And I think it's much better to have a bottom-up approach to learn from each other than somebody in Brussels telling you do this wrong or grading. So I think that is a very good development. About the charges, just to add to what you said, is it what defines the charges, what airlines pay? In the past, yes, it was about the planned route, and so they planned and then they flew something else, but that has now changed in RP3. So it's what is actually flown. And it's an interesting discussion also with the airlines, and I think there are people here from airlines. They say one solution would be you have a unit charge all over Europe. And they say, oh no, God forbid, that is the last element of competition we have. So it is a good competition to that there are different set of charges. And last observation about that, you said several times, 97% is really good. Of course, it sounds like really good, but unfortunately, in FABEC, not everybody has reached the best flight efficiency and the targets. And the network manager already calculates what is also including the optimal in terms of cost efficiency. So there is room for improvement, at least from the PRB point of view. Would be great if all FABEC states would reach the targets of horizontal flight efficiency.
Thank you very much.
Maybe one word to the just one word to the benchmarking. What we are doing, I didn't mention that before. We have, as you said, bottom up. We have two activities. One is a more scientific approach where we take all the sectors and take all the informations we have and compare it. So this is a technical thing. But on the other side, we have, and we all know the comparison between the FAA and Europe. And we said, well, let's do it on an operational level. We have a group of air traffic controllers and supervisors from FABEC, from all FABEC partners. And we have on the other side of the Atlantic, we have people from the FAA. And they're doing now operational exchange. And that is very interesting if you put controllers together, not only the people who are analyzing data, but pure controllers. And that is very, very interesting. How do you separate it? How do you work? Do you have a planner and an executive on the position, or have you only one? How is your supervisor dealing with openings, closing the sectors? All these things, that is very, very important. So thanks for that, yeah. And as we sort of think about these broader questions, which are now drifting a little bit away from the environmental as well, but there are I think, some very, very big questions in front of us, because the current charging scheme, well, it's broken, and we've got to find a way of moving forward sustainably for the companies and for the ANSPs and for the airlines, as well as in an environmental sense too. And the single unit rate across the whole of Europe, yep, that's one that's going to keep popping up, I've no doubt. But another question, a fundamental question, is what is it that an airline should actually be paying for in the whole game? And I think those are some very big questions that will come up in the future, and they will also have an environmental slant to them. Whether an airline should pay for what it uses, or whether an airline should pay for available capacity, and whether it's got some kind of an environmental part to it. Now, let's turn to an airline. Eric Nantier, Swiss.
I come exactly on this point. First of all, I like the comparison between McDonald's and restaurants or French guys, you could imagine, where I'm showing on an ATC point of view, and I say ATC and not ATM, I make this difference every time, could you imagine? I'm looking between McDonald's and Burger King, because the service that I receive from different ANSP is more or less the same. Obviously, the difference is not so high as on McDonald's and the three-star restaurant from Michelin. But the difference of the price is very high. Mm-hmm. And saying that we as an airline, for the sustainability point of view, we have to take the most expensive one because the NSP didn't do their own job, I think is something you make a wrong analysis. Mm-hmm. It's your job to make the service correct on the correct price and not asking the airline to pay more what is necessary. When I discussed with NSP, I was Friday with one saying, from my point of view, you are about 20-25% too expensive for the service you are delivering. That's the first point of view. Second point of view, OpenSea, I don't like the average value. 79% or 97% is very well, it's great. It could be better, regular is right, but it's depending where you are flying from and where you are going to. Because ENM in 2019, etc., make a beautiful way from west to northwest to south, Grecian, etc. And if you are flying through this way, then it's a totally wrong value. I could say for Swiss, we were about 15% bad than the other one because we are not on the way we was, I would say, prioritized. As a place, when you speak with percentage of value, you have to correct sometimes these kind of things.
So what I'm hearing there as well is the need for us to make sure that we're more granular when we look at the data. Obviously, some things like that, but that doesn't tell the whole story. That's the point. Okay, that's very good too. Last question before we finish for lunch is a Slido question. I'm going to read it out to make sure I get it right as well. The EC is claiming that the Single European Sky 2 Plus recast is targeted towards better environmental sustainability. According to you, which part will help improve the situation? I'm not even sure I'm looking at you here, Wolfgang, for that. I'm looking at all sorts of other people. Is there anybody in the room who has a bit of an answer to that question? Because I'm not sure I do. Do you? Ilona, do you have an answer to that, which we could maybe pick up this afternoon in terms of the Single European Sky 2 recast of the legislation?
It's not an easy question, but I will try to touch this in my presentations later.
Brilliant. We'll tackle it like that in that case. Thank you very much, Ilona. And Wolfgang, thank you very much to you as well for your presentation there. Thank you.
Thank you, Alex.
And that then brings us to our lunch break, and we've had some good and interesting inputs, and thank you to the questions as well and the comments, because I think all of this then just increases the amount of things that we are thinking about, need to think about in this topic on our way through. And answers today, we're not going to have a whole bunch of answers today, but what's far more important is to know what the real questions should be and to know what we do with those. So we now close for lunch. We will be back at 2 o'clock, 1400. For those in here, we'll be eating in Funky Claude's, which is just next to the Montreux Jazz Cafe. The restaurant itself is a sit-down separate area, named, of course, after the guy who founded the Montreux Jazz Festival, Claude Nobbs. And hopefully you will all be able to enjoy a nice meal together there. For those of you at home, I hope you enjoy your meal as well and join us next time. But to everybody, back at 1400, bon appétit. Well, ladies and gentlemen, I think we are certainly all back here, hoping that the people who are online are also joining back after a good lunch. Thank you to the various teams who organised that lunch as well. It was a very professionally done thing. And also, again, it's remarkable how different it feels, almost how weird it feels, but how good it feels to be sat down at a table with people that aren't just the people in my family as well. So that's great. So the next couple of hours until 4 o'clock, we now have a presentation about environmental performance and how we're going to talk about how we think about actually measuring and managing that performance. And then we have a panel session which will range over a number of different areas and hopefully start to bring in some of the things that we've been talking about this morning as well, before we then get to the final wrap-up session. So I'd like to hand over to Ilona Sitova, who is from MUAC as well. And she is the chair of the Standing Committee of the Environment, and therefore somebody who really is in a very good place to talk to us about this.
Thank you very much. Good afternoon to everybody. And in my presentation, I will go to environmental performance. As all operational issue was already discussed, we need to talk how we measure environmental performance, how we can improve it, and what we can do to improve this and way forward. So we can start, our contents of my presentation following them. I will start with former difficulties, then I will describe the current challenges. It's already, most of them already mentioned, but still identify causes on inefficiencies, then mentioning interdependency, and then how we prepare to new solutions. And then, of course, we will come to conclusions. So, first, former difficulties. It's a difficulty sector we met in the past. So if we are coming back to many years ago, then our aircraft performance engine was not so good. The emission was very high and aircraft was very noisy. As well, we had very segregated airspace. The civil and military airspace was apart. Civil were not allowed via military airspace, and flight efficiency was very low. So we had a fixed route network. Then capacity was always higher than environment. And we had very basic measurement of flight efficiency. But it doesn't mean we didn't do a lot for years. We've done a lot. Since years, we due to technological advantages and our work, the reduction of CO2 emissions improved by 80%. Then noise improvement more than 75%. And emission avoided more than 10 billion tons. It's a lot. Then fuel burn per passenger per 100 kilometers in 3 liters. It's 3 liters now. It's comparable with road traffic. And then flight efficiency improvement, almost 1.1% every year. So as you see, it's done a lot, but it doesn't mean we cannot do anything more. We can and we should do. So, and then to do this, we need to know where we have problems. Problems, it's inefficiencies. Inefficiencies can happen in any phase of the flight. So it's from departure airport till destination airport, from taxi out inefficiency till taxi in inefficiency. And concentrated on inefficiency on climb phase, we can see inefficiency during departure procedures like seat, leveling off, inefficiency during descending procedures, holding stars, leveling off as well, noise. But all these inefficiencies were described in previous presentations as well. And then en route inefficiency. You can see a long list of inefficiencies during en route phase. This is fixed route network already mentioned, segregated airspace, congested airspace, expensive airspace, adverse weather, of course, contrails, landscape. So, but we need to know this inefficiency because if we can, and to measure them, because if we cannot measure it, we cannot improve this. And still, we divide the flight for horizontal flight efficiency and vertical flight efficiency. It was discussed, mentioned already before. And so, again, I highlight a good performance measurement understanding is needed. Going a little bit deeper to inefficiencies. And on this picture illustrated, I think, quite well. So, its dotted line is optimal trajectory. And as you can see, what does it mean, optimal trajectory, in our understanding now? Flight is unrestrictedly climbed till top of climb. And then its flight goes up optimal flight level during the en route phase. And then flight descent, using idle descent actually, to airport of destination. So this is optimal profile with minimum fuel burn, as we consider today, using the Great Circle route. It's this optimal profile based on the shortest route. So what is the inefficiency we can see during the flight? First, it's of course was already mentioned, restricted airspace. Flight should go around the military area booked for safety reason, of course, and we cannot avoid this. Then adverse weather. We cannot go via thunderstorm areas. So then aircraft operators may consider to avoid expensive airspace or congested airspace. And as well, contrails may be avoided. Then aircraft may be put on hold in terminal area, in arriving terminal area. So, and then aircraft may descend not continuously, but with steps, as you can see with previous presentation, it was explained by Peggy. And as you can see from this picture, all these restrictions are not dependent on INSP performance. Some of them are some of them, INSPs cannot influence at all, like weather. For another, needs the cooperation between different actors, like restricted airspace, or expensive airspace or congested area. It's like managing the environment versus capacity. So that graph illustrates the previous saying, interdependency between different areas. So this graph shows us traffic volume, it's a green line, and flight efficiency, it's orange line. From year 2016, so several years shown here, it's quite a lot. So as we can see, the orange line follows green line, and correlation between flight efficiency and traffic, it's 0.9%. It's very high correlation. It means the correlation almost linear. What does it mean? It means that if traffic goes up, flight inefficiency goes up as well. If traffic goes down, flight inefficiency drops as well. So, as we can see, that lowest traffic ever was in 2020, April and May. And during this month, we had the lowest ever flight inefficiency. Unfortunately, I could say, if traffic goes up, we could expect increase of flight inefficiency as well, as this factor has a big correlation to each other. So this shows interdependency between factors. As I said, managing environment versus capacity, environment versus cost effectiveness, and we can say environment versus safety, but safety comes always first, and we never compromise safety. This is a little bit a different thing. Safety always goes first. And then how we measure flight efficiency or inefficiency. So now we used actually, for coming back to previous slides where I mentioned we have vertical flight efficiency and horizontal flight efficiency. So we start with measurement of horizontal flight efficiency. In our day, we use K and CAP indicators for horizontal flight efficiency based off achieved distance concept. And actually, INSPs are not so happy with these indicators. I will explain you why. And this picture, unfortunately, I cannot show, but I will try to explain to you what is going on. We can see on this picture, we can see the great line, great circle distance. So the shortest possible distance between two airports, origin and destination, O and D. And actually, the most efficient flight should go on this line. But what happened? Instead of sending aircraft to D, aircraft was sent to point N. You can see it on the picture. So extension, fly extension is created. Fly extension is inefficiency. So, and fly extension is created in airspace, in blue airspace, in the first airspace. And if we measure flight efficiency for gray airspace using K and CAP indicator, even in gray indicator, in gray airspace, flight is sent directly to the destination. Inefficiency created in blue airspace still will be staying with inefficiency of gray airspace. That's why that's CAP OK indicator doesn't show really improvement made in single airspace because it's kept in efficiency made in previous airspaces. That's why these metrics fail to measure INSP's behavior. And these metrics are not really suitable for small airspaces. Then we come into CCO, CDO indicators, we already discussed during this morning. What problem we have there? First of all, it's binary metric. So this metric does not give us fuel burn or extensive fuel burn or anything, only 0 or 1 binary metric. 1 means there is CCO, CDO exists. 0, there is no CCO, CDO. Okay, and this binary metrics based on leveling segment. If there is leveling segment exists, then there is 0. There is no leveling segment, there is 1. So what is the deficiency of this matrix? We cannot convert it to CO2 or fuel burn. And second, even if there is no level segment, it doesn't mean there is idle descent. Probably its aircraft need to give the power and to use engine to be able to reach the destination. So that is mean these performance indicators are difficult to understand, interpret, and to use to improve INSP performance. What is very important, we are not able to use them to improve our performance. But we know our metrics needs to measure performance and to identify inefficiencies. So, and we are working, of course, and new indicators are needed, and we are working on this. We are working on this hardly. In October 2020, ITM INS Environmental Transparency Group was created. It's chaired by Eurocontrol, MIOAC, and NATS. These proposed metrics could be used for RP4. So, and FABEC members are very active members of this group. And some proposals for assessment is done by FABEC members. I just mentioned few of them. Acropole metrics comes from DSNA. Acropole metrics is integrated metric based on computer artificial intelligence solution and enables in real time to calculate fuel burn or CO2 emission. Then Redus-Raster metrics come from MIOAC. These metrics are suitable for measuring of horizontal flight efficiency in single airspace. this matrix doesn't have deficiency of K and CAP indicators. Then new matrix trajectory comparison indicator, case MNATS. This matrix, it's proposed to compare different trajectories. For example, file trajectory, then actual route, then theoretical city pair optimal trajectory, etc. Compare all these trajectories to each other, we can identify responsibilities of different actors. TMA indicators proposed by LVNL case Eurocontrol. It gives us possibility to measure excessive fuel burn in TMA. So again, I repeat, we need better indicators to measure INSP's progress toward European net zero emissions goal. So, but we were talking about CO2 emissions, but we should not forget about non-CO2 emissions. What makes probably even better impact of climate change than CO2. A lot of research still needed to identify this impact, but it was done really a lot in last years. So CO2, non-CO2 contributors, it's NOx, particles, contrail cirrus, etc. They're quite large in aviation. And to be honest, we can say some of these contributors may have a positive role for climate, but it's a small part. Most of them have really negative roles of climate and contrails. Contrails, the biggest contributor of aviation of climate change according to recent researches. And it's larger than CO2 emissions. But I should say CO2 emissions stays more than 100 years in atmosphere, and contrails may last from several minutes to several hours. But contrails may create the cirrus clouds, and cirrus clouds, of course, make this greenhouse effect. The effect of greenhouse on Earth very large. And contrails, just to remind you, contrails is a nice blue string on the sky we can see on the nice day. It's a picture above my house, by the way. Okay, that is why MUAC is running now a contrail prevention trial. And actually, we are the first in the world who do this. Because we're running, it's not a theoretical thing, it's operational one. It's a real operational trial. We at MUAC trying to avoid contrails during the nighttime, because at nighttime contrails have biggest greenhouse effect. So, what is the purpose of this trial? First of all, to prove that contrails avoidance possible from using the meteorological forecast, and also it's possible operationally. So we sent aircraft lower or higher of area where contrails could be created. This area called ice supersaturated area, as for creation of contrail needed very low temperature and high humidity. So where ice crystals could be created and contrails and cirrus then exists. So aircraft, we don't send aircraft higher or lower than 2,000 feet, then excessive fuel burn is not so high, I would say. Because its contrails happen, SSR's area happens on a high altitude, usually. And we are doing the trial every second day. And results will be available at the end of the year, because trials is running from January 2021 till December 2021. So it's what we were talking, what all this effort we are doing, it's to meet the European very ambitious target of zero emission by 2050. So just several figures. European Green Deal It's reduced transport emission by 90% compared in 2050 compared to 2019. Then we can see the share of aviation in worldwide CO2 production now 35%. In share of aviation in transport, it's about 14%. Then we can see in an ATM and efficiency, but ATM and efficiency here, I mean not only INSPs, but airlines, airports, etc. Altogether, it's 10% about aviation emission. And so it's a decarbonization roadmap to European aviation. It's shown here, but I will not go in details because it was done by Peggy in the presentation this morning. But here I can mention the reply on a question asked this morning as well. That's what is the CES top 2 plus contribution in decarbonization. In recast of CES 2 plus, it's nothing directly shown of reduction of CO2, but indirectly via cooperative decision making, by improving of airspace structure and collaboration, we can reach a good result in improvement in environment. That's why I'm coming to collaboration. It's only if we're working together, we can reach a result. So it's a collaboration is the key for environmental improvement. So significant reduction of CO2 is possible only if we all work together. So, but INSP could be a driving force in this direction. INSPs could initiate all these programs what would lead in reduction of CO2. Which program we are talking about? Almost all of them were already mentioned during the morning. So this is, of course, free route airspace projects. And now we are more and more talking about cross-border free route airspaces. As free route airspaces, it's already implemented almost everywhere. And is, as Wolfgang was mentioned, that it was already done by tactical level even 20 years ago. Then CCO-CDO implementation, also mentioned advanced flexible use of airspace. Now we call it advanced flexible use of airspace. It gives even more improvement of flight efficiency. We should remember that airspace is a scarce resource and we cannot expand airspace to make it bigger. So we should use it flexibly. Then, of course, for the trajectory-based operation, now it's a lot of partners work on this, to be able to allow controllers to choose most environmental friendly route, for example. Then contrail avoidance, I just explained to you. Then we should not forget cooperative footprint of our buildings, our mobility, etc. We are, by coming every day to the office, we are producing CO2 as well. So we should measure this, of course, and to reduce this impact. And the last not least, as I usually say, we say, so we should promote environmental awareness of the staff, of all staff working in our industry. In addition, we come to the meteorological thing, yeah. We should remember that not only aviation influences the climate, but weather also influenced aviation. And with climate change, weather becomes more and more unpredictable. And we can see the more and more severe weather phenomena every year. So how actually what and how we can do in this area? Not from operational, just from performance point of view. We, instead of using the shortest distance optimal profile, we should start to use optimal profile that could be based not on shortest route as it now, but also this profile should incorporate meteorological conditions like wind, temperature, pressure. If we incorporate this meteorological condition, we can reduce the fuel burn. So where it can be used? It's not my slide. This slide comes from Meteor Alliance. We are cooperating. FABEC has a project with Met Alliance, and we are looking forward how we can do this and how we can improve the meteor predictions and what they can do for us. On the picture, you can see prediction of thunderstorms across Europe made by Meteor Alliance. And in conclusions, a great effort has been made to reduce environmental impact of aviation with horizontal flight efficiency now above 97%. This figure already repeated several times, but it's really true. Current environmental performance indicators do not provide a good measurement of INSP's performance. Better indicators are needed to measure INSP's progress toward European net zero emissions goal. Recommendation for new metrics will be done by ATM and Europe Environmental Transparency Group, in which FABEC actively participates. Further development of FABEC environment project like FRA, FUA, CCO, CDO, EXMAN, contrails prevention, etc. will reduce the impact of aviation on climate. And the most important, collaboration between operational stakeholders is the key for environmental improvement. Let's discuss.
Thank you very much indeed, Ilona. Thank you. So there's quite a lot in that that I've taken away. The first thing possibly is that environmental efficiency starts at home as well. So it's not just thinking about the airspace, but also thinking about our own footprints back at home with our own companies and what we've got there. I also picked out there very, very loud and clear the collaboration piece again. So that's coming across very strongly too. I've got a couple of questions, specific ones for my understanding more than anything else. The transparency group that you mentioned, what level is that? Is that a Eurocontrol group? Is that a European Commission group?
All European INSP are involved and member of the group. And actually the Council is also participated in this. Barelius Airlines, FABEC, we have sometimes it's common decision and we push it to this group. So yes, it's involved whole Europe.
Thank you. But it's at the moment it's European ANSPs, or because there's something there for me as well about the making sure that when we have a look and come up with metrics at the end, that they're metrics that mean the same thing to the various other actors in the game that we're talking about. I was also interested to see the non-CO2 contributors, that could potentially be an even bigger effect and a bigger amount than CO2. And that leads a little bit into something I think we'll come back to in a short while as well, which is what else don't we know about yet? Because, of course, we are discovering things at a relatively rapid rate. And there's presumably a definite risk that if we make metrics too soon before we understand the whole ecosystem, we end up with metrics that actually drive us in the wrong direction as well. So that is presumably something that comes up there. Who's currently at the forefront of this kind of research? Is it in Europe? Is it elsewhere in the world?
Yes, it's Europe. It's Europe, and it's Europe is leading this research. DLR, German Airspace Center, we could say, it's very, very active in this. In Germany, there is this, it's a project going on contrails avoidance as well. And then Metropolitan Manchester University. There are leading scientists working there as well. They published also quite a lot of paper on this subject. It's UK. It's still Europe, so it's...
Geographically, anyway, yes.
Yes, it's Europe is leading parties here, but it's a lot of interest in America as well. For example, we were contacted by Google. So I think they will follow. And definitely in Asia as well. In some papers I've seen done in Japan.
Okay, so there's something quite interesting. I mean, this is now global politics, of course, as well, but that maybe different regions might have some different speeds as well, depending on how important it is to the politics of Europe compared to the politics of South America, Africa, or China, or whatever. So that's something else just to be thinking about as well. Another question for my edification: the contrail trials. So the first question is, how sensitive in a height band are contrails? I mean, if I go 2,000 feet up, do I stop contrailing, or do I have to go up 5,000 for that?
It depends. From experience, I would say now we have a half a year experience with this, as every day we're looking to contrails in the sky, actually. It's actually our theoretical expectation, a little bit different what we met. Mm-hmm. It could be the difference, thickness of this ISSR area. And usually it's not so thick. It's indeed, we were able to avoid contrails by sending aircraft 2,000 feet lower usually we send. So, but sometimes they're really thick, then we are not doing contrail avoidance, because it's indeed, we cannot send aircraft or 10,000 feet somewhere or whatever. No, there is no way. But it's also the difference, yes, in the contrails level. It's usually above 300 flight levels, yeah? It's in this area approximately. But at winter time, contrails are lower than in summertime. It also depends on season.
No, absolutely. And so who determines whether the aircraft is contrailing? Can the aircraft tell for itself, or does that require someone else to look and see?
We hope this is a future. Aircraft self-look into this ISSR area and self-avoid this. I really believe this is future. Okay. But nowadays, it's not the case. Nowadays, controller who see the ISSR area on screen and who actually warned by supervisors in the center, how it's done in our case, then send aircraft lower or higher. So propose aircraft to do the contrail avoidance.
And there springs the link, of course, then to the Met office as well, and to where such an area exists, presumably too.
Yes,
that's obviously
not and we need the close cooperation with Meteo services to have this contrails prediction very good one, almost surgical. We can, because we don't want aircraft spend fuel just to avoid in areas where there is no contrails. You see, so it's.
And do you know, as well as part of this trial, how much of a trade-off the airlines have to make by going, let's say, 2,000 feet lower in terms of their fuel efficiency?
According to our calculations, it's really not a lot, because contrails area, it's not so big, first of all. But this stepping, it also takes additional fuel. Okay, of course, we admit this. But on such altitude, this 300 flight down, it's something like 50 kilograms of fuel for avoidance of contrails. So it's or even less. It depends, of course, of distance flowing.
So presumably one day we should be able to make some kind of calculation that says if I burn an extra 50 kilograms of fuel, produce an extra X amount of kilograms of CO2, how much have I managed to avoid because there's now no contrails there, to get some kind of a comparison. Okay, that's pretty good.
May I add, sorry, it's just estimation because we don't have results yet. Please don't take these figures as a final claim or whatever.
And there was one other part before I throw it open to the audience as well that I thought, well, I'm not sure whether to be depressed by this or whether there's some way out of that, but that is the relatively linear correlation that you were showing between the traffic levels, between the delays, and between the flight inefficiency. In other words, they're pretty much directly related. And the big question, therefore, is what is there that we can do as the traffic recovers, and I hope it will recover very soon, to make sure we don't go straight back into the same level of flight inefficiency as previously? Have we done anything in the last year that's going to make the big difference there?
Yeah, I can only repeat this list of the project, what really help to improve environmental performance. There's free route airspace, now it's cross-border free route airspace, then of course fuel, advanced fuel, and RAD lifting, etc. So this is really helps, and this will allow us to break this linear, but I believe it still will stay. Probably with a lower coefficient, but it's, I'm afraid we cannot avoid this. With the rise of the traffic, flight inefficiency will rise as well.
Okay, so there are some things that have been delivered now that will hopefully help us, but we've obviously got our work cut out there in order to make sure that it doesn't go straight back to where it was previously. Thank you very much. Looking around, so we'll start with Mark simply because he's closer to the microphone, and then we'll go to John.
Thank you very much. Question on non-CO2 and the contrail work you described. How confident from a mathematical or scientific point of view are you with what you are doing? So is it rather 0.1 or is it rather 8? So how far are you sure what you are doing has an impact you actually theoretically model? Second point on this, how do you avoid to create the contrary in your trials? So how are you sure that in the trials you avoid really the right area? Okay, so what kind of tools do you use? And then if I may, last question, I asked before to Peggy, 6%, how far off are we from zero? You mentioned 10%, how far off as ATM are we from zero for you, from your perspective? Thank you.
Okay, I will start with contrails. First of all, as I mentioned, research work is going on. And our trial based on the latest research work and on finding of German Airspace Center, who is leading research center in the Earth, I would say. One of the objectives of this trial to actually to prove they're right. So that's why it's trial. And at the end of the trial, we will get a result. Is it really we're using correct model? Is it really it works? So what means how we are going to evaluate this? We're going to use satellite images. Because, of course, we know when and where and which aircraft were deviated, and then we can use satellite images coming from meteor services to identify is it's indeed we managed to avoid contrails or not. And it's still a lot of work needs to be done to actually to look at all this data we are receiving now, because it's continuous, yes, to analyze this data and to make conclusions, of course. Did I answer your question?
One of them, yeah.
Okay, about 6 and 10%. It's a little bit different figures. 6% Peggy mentioned, it comes from a roadmap. Document, yeah, European roadmap, yeah, for decarbonization. And 10% it means what we can reduce, yeah, or it's the best way to deal with these environmental goals. The 10% it's the collaborate impact actually of ATM, including NSPs, airlines, and airports. It's from it's from destination, from departure to destination. Taking in consideration all European flight, and it comes from Eurocontrol report. It shows a little bit different, just excessive fuel burn. Or we could, compared with 5 or 10%, the best flight in Europe.
So that's then saying that this one's not just about the ANSPs and what they can do. It's the system, and I think Mark's question was also asking. So if let's say there is 10% available there, what's your guess as to how much of that 10% we can deliver? What are we going to be left with?
Yeah, this is a very, very difficult question. It's already, I tried to identify several times. I would say it's almost impossible to identify share of ANSP, to say, no, this is only our responsibility. Because if ANSP going around military area, what is responsibility there? If flight going to expensive airspace, who is responsible for this? If aircraft going around the thunderstorm, who is responsible for this? You see, and that is why only all together we can do this 6%, as Peggy already mentioned this morning.
Is it fair then to say, listen, we think there's 10% in the system, we think we can take out 6%, we do this whole list of things, but we're still going to be left with 4% inefficiency at the end? That sort of amount?
Yes, but it depends also how we can look at the different phases of flight. You see, it was mentioned today, for example, its biggest improvement could be done in vertical or TMA areas. Yeah, it's really true. Probably there it could be done a lot, because on horizontal flight efficiency, we are really close to optimal, saying again, we cannot avoid existence of military weather, etc., etc., etc. Even more, we try to calculate so precisely that these figures could be even marginal error.
Okay.
You know, so it's. We should also take in consideration and not concentrating only how we can improve on 0.01%, but look what we have done, what we're gonna do, and what it could bring to us.
Okay. That will be your third question. And I've forgotten what your second question was.
The first one was the confidence level of the contract.
Yep.
And what method you use
Yep.
to not do the opposite by avoiding contracts actually creating them. What kind of methods do they use?
Yeah. So that was partly answered by the satellite picture.
Yeah,
as
but
well.
satellite pictures. Yeah, we're gonna use
that.
this.
Okay. Can I move on? Are we good? John.
Yeah, I just wanted to add a few remarks, because my colleague here right of me was talking about courage, and I think this is a good example. So what I mean is, I got also a bit criticized that we do this trial, and I think at the end, this is at the end what we mean by taking courageous decisions and trying things with the best assumption, of course, not just out of the blue and with the support of scientifics, but I think it's never the good moment to put planes in another flight level, and I thank all the companies and the airliners who participated in the trial until now. Not all have been very happy, but only little have been not that happy, but it's never the right moment, and that's a little bit what we mentioned the whole day already. If we look non-stop about, are we completely sure, and is it the right moment, then we probably do nothing, anything, and that's a little bit where we need a little bit of support from all the actors. So I wanted also just to add that, of course, what we did not really realize is also a big challenge for the meteorological forecasts, because the forecasts of the Met services are not specifically now foreseeing such an exact forecast at different flight level of 1,000 feet about humidity and temperature. So in that sense, we are there also all challenged, and this is not a blame. We are happy to have the quality we have, but this is of course also something which would help us if this in future is improving. Thank you. But just to tell you about the numbers, maybe I should not say it loudly, but this is costing money, this trial, and that's what I mentioned this morning in the first presentation. So if you have an operations center like MUAC who is investing that money to do such trials, and if it's based on positive and right and justified assumption, this is just costing you what, between 400,000 and 500,000 euro just to do this trial, which is not nothing. And that's a little bit also something we have to be aware. If we want to move forward, we also sometimes need to be courageous and take some money in our hands and take a decision, even if not everybody will like it.
Can I just follow that on and link to something that's in Slido as well, which is how did you go about convincing the airlines to play along with this? Because it's not always in their own interests. And there's an additional sort of question there as well that says, is this something that we can then also use later on to incentivize the right behaviors in the overall system?
Well, maybe if I forget arguments, maybe Luna, you will help me, but I think the first thing is not an obligation. Second thing, we do it when there is low traffic. Third thing, we do it only during night. So in that sense, it's controllable and people know. And we also avoid to force them to move more than 1,000 or 1,500 feet. So we keep it in also environmentally seen in a level and in a range where you can still justify this effort.
I can add, most of airlines actually care about environment as well. And almost nobody reduced to participate in this trial. And some of them even connected us to offer the help in fuel consumption calculation, in all other things. And actually Airbus as well ready to help us with equipment is everything. This is a big interest from world to this trial, and we cannot complain they were not supported by airlines or aircraft manufacturers. So.
Very good, thank you, Ilona. And there we see some collaboration in action as well, which is obviously a piece of good news. Thank you very much, Ilona Sitova. Well done. And with that, we'll then move as seamlessly as we possibly can into the panel session. I'm joined by 4 excellent panelists. If the panelists would like to come down and join me on stage, that would be great. What I'll do is introduce them one by one, and then they'll give a bit of a presentation for 5 minutes or so, talk to us about the perspective that they're going to bring, and then we'll move on to the next one. And then we've got plenty of questions, I'm sure, and we see how that brings together some of the elements that we've been talking about so far. I'm going to go in the order that they're seated in, because that makes some kind of sense. So I'm going to start with Eric Nantier here, who has been working in Swiss for over 20 years and in the industry for a very large amount of time, with a lot of roles managing ops support, flight planning, policy, and we've known each other for a long time as well, Eric, various different conversations, trying to find pragmatic ways forward. You've been on the ops research and ATM part for the last decade, which is exactly how long I've been inside Skyguide. So that's why we've known each other that length of time. But also with links to César, and really quite importantly, I think ANSP, airports, and Eurocontrol links, which is this piece about collaboration that we've been talking about as well. And now operations optimization and development is your key area. The floor is yours. As is the microphone, as long as you manage to remember to press the button.
Thank you very much. It's okay, it's running. Normally, I finish my presentation with some sentence, and I will start with this one. As an airline, we don't just only fly aircraft. We move passenger. For me, it's very important that we don't have to forget that we are moving passenger. This is our job. That's the first things. I will be passenger-centric, and if we are speaking sustainability, because it's a theme for today, of course, is on side of the passenger, and I say no more passenger, but in this time I say customer on aircraft, but customer on the ground also. As a Swiss, as an airline, we are aware of the situation of the CO2 emission non-CO2 emission. We are aware also of the noise. It's very important, and the trade-off on this point. I listened to this presentation today, and it more or less it confirmed my part. As I would say, well, climb for us, okay, it's never optimal. Of course, we want the best one, but climb, we have it under control. That's true. En route, we are better and better. I would say do the free route, all this initiative, as Cesar done, is very well. Switzerland a little bit less because we didn't have to invest a lot of Cesar in the last 5 years. I think every time when I'm in the consultation, I ask the same question. It will be 15th of July again. Sunday, where we have to be and to improve clearly is the arrival terminal maneuvering area, TMA. Because we will never achieve our target if we send aircraft on the sky and expect that this aircraft will land correctly. And today, where we have the problem is aircraft are doing holding and vectoring. So holding and vectoring is not en route, it's every time in an arrival area where we are not optimal on the CO2 and not optimal of the noise. As I say, if we have to increase sustainability, it's really on this sector. Clearly, for us as an airline, every, I would say, unmanaged aircraft, from the principle in the delay, will implement automatically that we will correct it on a reactive situation and instead on a proactive. We will choose, do they make delay for the passenger, and the passenger is paying the bill, or do we fly high speed? Then we generate CO2 again, we make more emission, and most critical, we make high speed and finish with holding and vectoring. And then we make the cars. What I'm afraid from an airline point of view is, of course, if the productivity is going back in the next years, I would say this year already on the summer, on the peak time, on the weekend, we will have exactly the same problem as what we had in 19. If I'm looking the plan, I was looking the DSNR, I think 1.5 weeks ago, something like this. It's Friday for 10 days. We know already from the Eurocontrol that we will have day with more traffic than 2019, but less resource to manage this traffic. It's we will have delay, we will have holding, we will have vectoring, and the sustainability of the environmental target will not achieve at all. For Swiss, that's less 10 years, and we say you want it 10 years. We invest a lot of, I would say, on managing the arrival flow. We could prove with projects like iStream, with Xstream, that it is possible, but it needs something totally different. We have to change the paradigm. Departure flow management will never success. It's already clear, non-identified. So only one who is able to have 3 aircraft land or 4 land at the same time on the runway is a Swiss patrouille. But we will never have 3 Airbus landing on the same runway at the same time. It's not possible at all. We have to wait and to bring this aircraft. And this is managed by the NSP. And I will say, if the NSP, arrival NSP, you have no chance. Because it's depending on the other NSP, it's depending on the departure, airport, and is depending on the network manager. And I will finish with, I have a question of during the lunch, where someone asked me, who is the best ANSP? I think it was for me, the beautiful question. And I say very clearly, not with an ATC, air traffic controller, but an ATM, air traffic manager. And sorry, but today we don't have air traffic manager. We have only air traffic controller. And then we have to change the paradigm.
Thank you very much indeed, Eric. I'm going to move on each time straight to the next one. We'll take questions at the end for all of you. And we move on to Martje van der Helm, who is the head of strategy and capacity management at LVNL in the Netherlands. And a member of the corporate management team there as well. A lot of Martje's work is done and is about close collaboration with, particularly with Schiphol Airport, of course, in Amsterdam, delivering innovation and strategic improvements in the close collaboration with the various partners. So that's a nice link, I think, into what we've been talking about here as well. And because we mentioned DLR earlier on, Martje is also a member of the advisory board of NLR, which is the Dutch equivalent of DLR. Martje.
Well, thank you, Alex, and thank you for having me. Well, at LVNL, our purpose is enabling aviation together. And we want to do that by creating value for the Netherlands, for our customers, the airlines, and for our partners. And if you're looking at the Netherlands, we're looking at the society. Well, we mentioned it today several times. For us, that is reducing noise pollution and emissions. And for the customers, and too bad, Eric, you didn't mention LVNL, we are striving to a reliable and efficient operation. We know that we have international ambitions and goals for sustainability. What we did in the Netherlands, we made a collaboration of 20 stakeholders and we made up the plan Smart and Sustainable Aviation. We did that with 20 stakeholders, with airports, airlines, NLR, but also some universities. And it was mentioned before, what is really important and where I really believe in is that with close collaboration with stakeholders, we'll boost sustainability in the short term, mid-term, but also in the long term. And we should bear in mind that air transport is complex, it's diverse, and it can only be achieved by cooperation through international change. We started this initiative in the aviation sector, and the government joined this initiative. And this initiative has additional ambitions. So, for example, we want in 2030 the CO2 emissions of international aviation will be around the level of 2005. And CO2 emissions from land-based activities will be reduced to 0 in 2030. So what can we do as an ANSP? We agreed that 8% can be achieved by optimizing procedures and optimizing routes. And at LVNL, we have various actions for that. For example, we have the Dutch airspace redesign. One of the things that we are doing there is moving a military training area from the south to the north. So there's more space for civil aviation in crowded airspace. Another thing that we're doing there is creating an initial approach, an extra one, to improve the CDOs. And we have another program, it's called 1ATM. It's the integration with the military airspace. What was mentioned before, we have limited airspace that we can use. Another initiative is what we did together with the airport, Schiphol, is that we made a multi-annual plan to reduce nuisance. We came up with 43 measures. We checked that with the local government. And what we do there is we take different measures to improve the standard of living around the airport of Schiphol. And we cannot do that alone, because if you're optimizing routes in the TMA, you have to speak to the local people around Schiphol, because what's better for one can be a little bit worse for the other. So that is an example of how we are trying to enabling aviation together.
Thank you very much indeed, Martje. And on to the third panelist, Mark Baumgartner, who has worked for over 30 years as an operational controller, currently works just up there, a few hundred meters in the Geneva ACC, and has been since 2019 the chair of the Eurocontrol Performance Review Commission. And going back a couple more years than that, for a number of years, nearly a decade, up until 2010, Mark was the president and CEO of IFACA, which is the global organization representing 50,000 ATCOs worldwide in over 130 states as well. So Mark knows quite a lot about things around the world, not just in the small country of Switzerland that we're in. Mark, to you.
Thank you, Alex. Thank you also for the introduction. Today, I will try to bring you a few questions when we talk about all this new topic. The topic has become some sort of fashionable. And as always in aviation, when we get something new, we are fast and furious, and sometimes we tend to overrun the runways. So that actually the questions we would like to ask as the Performance Review Commission to the aviation system, this will then be published also later on this year, are a few hopefully helpful questions, which will also then make it a bit easier for all the stakeholders to frame the discussion, and in particular, at least that's what we hope, help also the ANSPs and maybe also the decision maker in the coming couple of months to orient their discussions, but also the initiative towards something which is really beneficial for environment. So there's a few catalogs of questions in my introductory remark. We started off by saying, what is actually the impact of aviation on the climate? And you heard it this morning. So we are more or less confident that CO2 has an impact, that CO2 stays very long. It was mentioned 100 years. I learned recently it can be up to 10,000 years, so that it remains in the atmosphere. So whatever we do has an impact on the longer run. We then also have heard on non-CO2 elements, which also are now coming up on the radar, and they have also a contribution. However, and therefore I asked the question before, the confidence level in the data, in the scientific data, is 8 times less than when we talk about CO2. So non-CO2 elements, the confidence we have currently in the data is actually 8 times lower than what we have in CO2. So there, the first 2 questions we have actually is, as we have a high level of uncertainty of non-CO2 effects on aviation, are we in a position today to take action in terms of operation and policy making, given the knowledge and tools available today? So we are actually risking the wrong decisions. So basically that means we should ask ourselves what kind of initiative we take. Because of its long lifetime and aviation dependency on liquid fossil fuel and the uncertainties attached to the non-CO2 effect, should the focus not remain on reducing CO2 emissions from fossil fuel? So these are the 2 first questions. Then we go on by asking ourselves, how big is the contribution of aviation? Also there we have different figures around, if you take ICAO, it's between 2 and 3% on CO2. In Europe, it has been in 2019 4.3% in greenhouse gas emission. And the challenge for aviation is the growth. So actually since 1990 until 2019, aviation has actually increased the contribution, the emission, by 125%. So the impact means that in 1990, greenhouse emission were actually 1.4%, and now they are 4.3%. And that, if we are confident that the growth continue as predicted before, that will continue this way if we don't do anything. So these are the next question. Then, what kind of simply substituting climate impacting flights? So here as well, distance, short haul, long haul, mid haul flights. We had, as Eurocontrol has published a train alternative paper, a think paper recently, where you see what kind of infrastructure you need to be competitive, even on a short haul flights, to be competitive as a train. It takes awful amount of money to invest into infrastructure to be competitive. Things like this. So it might be better to concentrate on the smaller percentage of long-haul flight, which ideally should be the first one to be equipped with SAF fuel, or actually fueled with SAF fuel, in order that you get the best positive results when it comes to CO2 reduction. This is really something which as a sector we might wish to have also altogether a discussion. So are the current discussions on the necessity of short-haul flights and proposed substitutes such as high-speed rail taking relevant factors into account, in tire emission life cycle, feasibility, emissions related to building new ride track. What is the cost benefit in the holistic assessment? And should efforts be concentrated to reducing climate effects on long-haul flights, which have the highest impact but the lowest potential for substitution by other transport modes? So there also you might have win-win situation, unexpected win-win situation, whereas we start to open up maybe a metrics bureaucracy on short-haul flight, but actually for the environment, it's not interesting. So this may be one of the questions we have to ask ourselves. Then, how to reduce impact on climate. Here, 4 points: aircraft technology, sustainable aviation fuel, market-based measures, and last but not least, improves the infrastructure and operation, so the operational efficiency. And then, what kind of contribution ANS could do to reduce CO2 emissions? And here I'm coming back to both the questions 6, 8%, 10%. We have seen different figures, so we don't really know. But this is a benefit pool. So in order to function, and maybe operational trade-offs, in order to function, you will never be able to reduce to 0%. So that is also, you mentioned 4%, Alex, before, but the 10%, the 12%, the 4%, which are actually shown around, that means, in another picture, that all the runners of the New York Marathon are running the marathon in 2 hours, 10 minutes. And this is simply not the case. So that also needs to be, I think, part of the whole discussion, that what kind of performance level do you need to achieve in order to make these benefit pool as small in the end as possible when you manage it. Otherwise, you raise expectations which might be completely wrong. And here also 2 or 3 questions to that. And I have already mentioned with regard to the confidence level of non-CO2. So instead of starting to invest a lot of energy and things like this, we might wish to first check and maybe wait for the results of this first trial. Thank you.
Thank you very much, Mark. And I will move on to Jeffrey then, from whom we've also heard this morning. Jeffrey is the Deputy Director of Ops at DSNA in France. Previously, he spent 4 years as the Head of the Environmental Affairs in DSNA, also 4 years with ICAO. He was, prior to that, the Head of ATS at Paris Orly, and he was Peggy's predecessor as the Chair of the Standing Committee Ops in FABEC as well. Jeffrey.
Thank you, Alex, and good afternoon, everyone. Thank you for the introduction, and thank you for inviting me to this great day on environment. We had some great presentations this morning and some challenging questions this afternoon. Let me go back to a clear picture for the ops people when we talk about the environment. We had some discussions today about indicators, about what we can do to improve, and not so clean-cut definitions of things. I think that for the controllers to be able to really do something, to have an impact on their daily activity, we need some clean indicators. We need to move for indicators for the experts to indicators that are manageable by the controllers, at least that they can understand it. Let me take an example. We talk about efficiency, but when we look at the scale, we talk about inefficiency. So there are things that are messed up here. When we looked at the first lockdown in 2020, we thought that the results for FABEC went up, meaning that the efficiency went up. Why is that? Well, because of the traffic mix that was involved. We cut all the long-haul flights that were, in fact, really efficient in the system. Getting rid of them lowered the efficiency of the system. That's exactly what Mark was mentioning before. Do we have to focus on one type of traffic or not? This is a decision that has to be made. It doesn't have to be one size fits all. It could be like a plane. You've got different phases in the flight, and you don't optimize the same thing during these phases. But we need to be very clear, I think, to what we want to optimize in each phase. There was some work mentioned it was this afternoon by Ilona. We've tried artificial intelligence in the final phase of flight. It's called the Acropole, and they try to match the FDRs on board, the noise recording on the ground, and the radar tracks. And they try to aggregate all that into a simple, clean indicator for the controller to manage at least the dangerous phase of flight, too much energy, the noise, and the fuel burn. If we can aggregate that, this is something that is very legible for the controller and be able to manage the whole system. Second, there was a big elephant in the room this morning, and let me talk about it again this afternoon. In the world before 2019, we were looking at the delays, and then we were looking at the environment indicators. Are we ready to do the opposite today? And say today, well, we want to have improvements in that, and then we'll see what we have in delays. Are we really ready to do it? This is an open question. It's really something that we have to deal with. And I will give you one quick example. We're trying to do trials with some air carriers for departing Paris-Charles de Gaulle and Paris-Orly. They're trying to do their best to do their continuous climb operation, but we're not talking about only flight leveling. They will really adjust their speed and their consumption. First, to reduce noise. We have a specific trial on noise, and we've got a specific trial on consumption. Basically, they will follow tracks in a different way than we do before, than we do today. I mean, because they also worked on artificial intelligence to try to get the best out of it. Well, when we look at the flight profiles, they're really different from the other flights. So if we let them do really what they want, we're going to have to reduce capacities, because now the flights are really leveled like this between Orly and Roissy to join all the upper routes. If really they change the way they fly, we're going to have a problem to keep the same capacity level. So it's really something that is challenging. This is the time to do it, obviously, because we've got less traffic, and we'll see what the results are. But this is really something that could be a game changer, and it goes back to what I was saying. The third point I would like to make, we need political support on that. Really, we need, and I'm not saying that we are not involved in that, we can make proposals, but we need political support to say, okay, this is what we need to do, and we have to explain it to the communities, we have to explain it to the airlines, we've got to explain it to our controllers also even, because sometimes they have an idea of what to optimize, and sometimes this is not the right thing. But we need this political support to be able to keep the decisions that we take and enforce it. I will give you an example. We changed all the arrival trajectories in Paris in 2012. Basically, again, it was a noise distribution change. There were some side effects of the change. It was done only for environmental purposes. So the Ministry of Transport totally supported us in this change. I can tell you that if we had done this change for capacity purposes, this project would have stopped, because communities could be very vocal, and especially the ones that are newly overflown. And this is very difficult to implement. So as long as we don't have this decision and support, it's going to be very difficult to do the best out of the two worlds. We need to have this thing really clarified. Finally, is it the right time to do it? We said this morning, yes, it is. And in the meantime, we know that it's going to be very difficult for the airlines to be able to pick up their activity if we add more constraints, even environmental constraints in the system. Is it the right time to do it? This is not for me to answer, but this is also part of the problem. It has been addressed by John, and I think it's really a nice question. And finally, I think that Mark did a good remark, and should we only address some part of it, because we know that we have a big impact on that, and this is a safe way to start. So I think these are all good questions to integrate and to be able to answer. Thank you.
Thank you very much indeed, Jeffrey. And I'll just take your last point there. What I'm hearing from that is also to say, what we're not going to do is we're not going to just simply wait, ask for more data, wait another 10 years and keep asking for more data before doing anything. It's necessary to do something now, but therefore presumably the thing that we need to do to start with are the things that we're sure are going to make a difference anyway. I'm just going to fire a question at each of you, but I'm going to start at the far end, Jeffrey, because you're still speaking anyway. Your open question that you left in the room was actually, I thought, very similar, probably pointed in a similar direction to Rob Peters' comment earlier on. And if we now look at what we've got and we're looking at this recovery, is there, in your mind, whether you're now speaking for DSNA or FABEC, is there a way to shape that recovery in an environmentally beneficial way?
Oh, I think there is. We're starting removing red restrictions, and some people said before, well, this is not possible. And this is only because we have this current situation that it was possible to remove them. And then, yes, they might be reintroduced, but we're going to reintroduce them because we really need them and not because they've been there for 25 years. So we kind of reshuffle the cards. Mm-hmm. That's really the thing. And if there's really a real backup on this environment priority, yes, we can really explain the controllers and change the shift. It's not when I have time, I will take care of the environment. It's I will take care of the environment, and when it's really too busy, then maybe there's going to be other things going on. So I think it's really possible.
So for you, this is the time when there is going to be that switch of the prior, or at least a balancing of the priorities.
Exactly.
Yeah? Okay. Thank you, Mark. I suppose one of the questions here for you as well, especially with the breadth of view that you've got, is to come back to one or two of the things that you've been talking about as well, and to say how do we go about attributing responsibility to the various actors that we're talking about? We've got a lot of people, a lot of companies in the system. How do we help ourselves and them to attribute that responsibility?
A very difficult question, because it comes back to who is the arbitrator, who is doing the arbitrage. Is it the climate or is it the costs? So if you talk about cost, about survival for airlines, about passenger costs and things like this, we need to continue to focus on capacity. If somebody says we want to save the planet and we want to manage the CO2 impact of aviation, then this becomes the priority. And that is I think somebody mentioned that before, it's a societal challenge. Having said that, the idea is to manage it from a gate-to-gate perspective. So that means you create already a framework, that you don't stop at political borders. That is also, transatlantic and things like this. It is a meteorological system, it's a climatological system. So whatever we do in one part of Europe has an impact in the other part of Europe. That creates another sense of urgency, if you want. And then, of course, a body like this, a functional airspace block, can help, but it cannot help without the British or the Irish colleagues. So that is certainly something where you then need to bring together, in order to achieve these potential in the system, to bring together the scientific community with decision makers, and then let the actors, the ones, airlines, ANSPs, and also the airports, follow certain of these things. But that really, for me, is a societal question, where the Commission, for example, for the Single European Sky states, needs to say, well, we want to save the planet. But then the whole discussion on SCS2, on RP4, changes completely of scope. And I'm not sure if we are ready for that.
And so there's quite a lot in that, but one of the big pieces, of course, is a reminder to all of us that whether we're thinking our own airport, whether we're thinking our own ANSP, whether we're thinking FAB, it's not thinking big enough, because there's always a border to something else, and we've got to think outside those borders as well. And there are a lot of dependencies. I think it was Eric that mentioned the dependency. Actually, your landing runway depends all the way back to the D-man, the departure manager at the point of departure. So all of those players have an interdependency in there, making it all much more complicated. Okie doke. Yes, I don't think that made the world any easier, did it? But it highlights some of the challenges that sit in front of us. Martia, when Peggy was talking, on one of her slides, there was a word about the word compromise came up very, very clearly there as well. And how do we go about having the conversations, because there are compromises to be made, trade-offs or compromises, how do we make sure that we have the compromises in such a way that they're not just a lose-lose each time?
Well, I think at some points it will be difficult because there are different parties with different stakes. If you're looking at the TMA, I think to achieve sustainability goals, it requires customization, but it requires also working together. And sometimes I think there are win-win situations. For example, we are improving the outbound flow with introducing a new departure manager. Well, that's good for Schiphol, but you have to look to the whole system. So you're talking about boundaries. I think it's really important to talk to your stakeholders, to understand the system, and look what's the effect of your action.
Thank you very much. Moving to you, Eric. In terms of, we've talked a few times about, okay, environment. Is the environment going to start to take a higher priority? Can you see the day when, for an airline as well, the environmental aspect is going to outweigh or at least balance up to the cost aspect?
I would say we make it since the beginning of aviation because environment CO2 is a measure of how many fuel we are burning in an aircraft. And our job is to make the most optimal flight. Doing the most optimal flight is to burn as less as fuel as possible to achieve exactly the same target. Of course, as an airline, we make probably the biggest, improvement and investment in this sector, purchasing regularly new aircraft with better, and if you are looking at the value, what an airline will bring? Much more than all others together, because we are permanently investing in new aircraft. We make less noise, use less fuel to transport exactly the same number of passengers. Like I say, I don't know who write it, is the 3 liters per 100 kilometers per passenger. Yes, we are more or less today below this value. It's any person who are driving with a car needs more fuel that way when we transport a passenger. And it's something that we try to improve. We have a new aircraft. Most important thing is sometimes you have to be recognized. We have a new aircraft is coming, absolutely new, the new A320 Neo, etc. They are coming. And then, of course, from the regulatory plus, we become, I would say, some weeks or months later, new rules, and all these aircraft are no more able to cover these things. You are thinking as an airline, okay, it's difficult, but yes, of course, we take care of the sustainability because for us, it's a direct, I say every time, fuel mal P, more or less, as 316, makes the number of CO2 we are producing.
Mm-hmm. And you just mentioned again the point about the passenger, which was the key sort of thing I took from your opening statement as well. And of course, that's true. It's sometimes for an ANSP, one can jump too quickly to just seeing the aircraft, the movement itself, and not having in mind the fact that the aircraft has a purpose in its own right, which is either moving cargo or moving a passenger. How might you go about actually actively managing that, especially in the competitive market that is the airline market, with either low fares carriers or carriers that are coming from outside the European area and the European Commission area? How does that pragmatically then get translated for an airline like Swiss?
It's okay. Yeah. If I'm looking for Swiss, we are not looking one flight, but we are looking the full network of the company. And depending on this situation, for the next about 72 hours, this is the next 3 days, we could try to find the best possible deal, I would say, between the delay and the priority on the passenger. As we try to organize these kind of things. In a competition between the other company, the most important thing is, for us as an airline, is if I could give the best possible priority to the flight who have the most important impact on my full network, I could optimize, I would say, the full journey of my passenger. I reduce the number of high speed who have a direct, I would say, impact on the environmental measure. And to do that, I have to steer correctly my wave or my principle. When I come in a competition, then the question is, and it's something that we discuss, is the equity between the different airlines. If I try to do something for more sustainable or more in interest of the passenger, and we don't measure the quality of this service versus the other quality, and thank you for the information, if you don't measure it, you are not able to improve it. I agree 100% with Ilona. None at this time, we will have a problem. I say every time, actually, we are still working as a measurement of the fairness between airlines with a first come, first serve. With, I would say, 70, 80 years old principle. What's nothing to do with the reality, and certainly no more something to do with the reality at the time we have an impact of the network. It's a day with something special like this, or snow, or very peak in the summer, or something like this. Then the first come, first serve can no more be the measurement of the equity between the airlines. Because in this case, you are controlling aircraft to aircraft on a flight, but not on the interest of the passenger. And open sea aviation is nothing else as a public transportation. We don't fly the aircraft for the pleasure. We are public transportation. We transport passenger in interest of the passenger, in interest of the community. And then we have to adapt this kind of thing. We have to change the paradigm, I think, at this level.
And that points up to something quite interesting as well that we haven't really touched on yet, but it's looking again at the system rather than looking at the individuals and saying first come, first serves works if you've only got 1 or 2 aircraft. But actually, if you want to optimize the network, you've got to think differently. And that means that we've also got to change the regulations as well that underpin that, because that's what we've got at the moment. Okay, I'm going to take a pause from me asking the questions and see if there's anything coming in from the audience that they would like to ask. Jean-Michel, you had a good question at lunchtime, by the way, so that would be...
Yes, so my name is Jean-Michel Hédard. I'm working for PMG, Performance Management Group of FABEC, and the Standing Committee Environment. So this morning I didn't have time to ask questions after the last presentation. It was about the indicator and the way we assess the performance of the traffic. And I said during lunch, for a joke, but it's not a joke, we have to work on the part of the flight. Meaning that in the first presentation, we said that the HFE is calculated from a circle of 40 nautical miles around the airport. So the objective is to measure the performance of the en route part. If you look at the 40 nautical miles around the airport, it's not enough. The SEED and STAR are going much beyond this limit of 40 nautical miles. So not the first things to do, but one of the things that we could do in a close future, it would be to update this 40 nautical miles. In the Standing Committee Environment, we all agree that this figure is not adapted and that is completely obsolete. So it would be a first way to change and to go for a better performance as the Commission can can see it. The 97% could be increased by, I don't know, maybe 0.2, 0.4, but it would be increased. It would be improved, and it also be a way also to go to better attribute the responsibility of this inefficiency and to clearly identify who is responsible for what. And this could maybe encourage the TMA to work in a better way for improvement of the asthma indicator. So that's what the first point. And the second point or remark or question was about a recent assessment analysis we did. We found out that without restriction, we don't have any more restriction. We can say we have restriction. Without a lot of traffic, we still see some airlines which are filing not the best option, I should say, meaning that sometimes they, in a certain country they take a longer route, or they file a weak route where it's the weekend, something like that. So, and if you look into details, you can see that if you compare the initial trajectory to the cheapest trajectory, it's the same distance. So it's something that we have to pay attention, and maybe to more focus on the interdependencies that we can see between cost efficiency and environment. We spoke a lot about the interdependency between ATFM or capacity and environment, but I think we should focus more or look more into details to the efficiency between the cost efficiency and the environment. And if I can make a third remark, Eric, when you said we need ATM, we have only ATC, we don't have ATM or not enough. Yes and no. Don't forget we have two kinds of people. We have the operational staff and all the others. As a former air traffic controller, I can assure you that we had pilot and controller a special behavior. In fact, it's quite difficult to have something which is flown, which is identical to what is prepared. So if we want to increase, or if we want to improve and reduce the gap between what is done by the operational staff and all the other world, maybe we should better educate our ATC and our pilots in order to reduce the gap between initial and between plan and actual.
Do you want to pick up the first point about the 40-mile rule as well, Eric?
I would say I could put the 40 miles. I would say for the 40 miles, at the time I have to analyze, and I analyze a lot of trajectory. Yes, it's true. We have to make analyzing of the gate to gate. And of course, the en route part, and I say every time, very often, people are measuring the en route part and the great circle distance. And often say we don't need to compare it to the great circle distance, but normally, if we will to be clear, it must be the SRD, that's a wind corrected distance with the best one. And that will be, and of course, TMA, as a departure and arrival, make a very big difference on the quality of a route. I will come on a second point, because you have 3 points. I will come on a second point. So route, of course, OpenSea, the flight planning tools that almost all airlines have are very efficient. All these ones are able to give you, we say, with $1 difference between this route and this route and this route. And of course, as an airline point of view, we have to be the most economical. As simple as that. And the question is, for me, and this I say this morning exactly, the question is why we have this kind of difference of price for the same services. If it's a McDonald's or the Burger Kings, and not a 3-star restaurant, like, why the price difference is so big. The kind of services is the same. And if you are looking in the detail, and we do it regularly, and I do it myself, yes, we have someone who receives a subvention to make investment from Europe for a CESAR, where it is no more coming in the cost. So the one has, I would say, the training is done by the staff for the first package or something like this, is helped to manage the price. At the end, from an airline point of view, we take the most economical one. But don't come to the airline and to say, be sustainable. I think this is a job of the NSP, of the state, to do the job, because, like I said, airline is a public transportation. And the third point that you say for an education pilot, every time when someone asks me, fly the flight plan, I say every time, our pilot, they push a button, load the flight plan in the FMS, and then it's a flight with flight plan. They don't have to do anything. And normally, like I say, our tools are very efficient. So I'm quite sure that the flight plan is the most efficient, and then we don't have to try to make something else. If you have the most efficient flight, why you have to change it? Why you have to make another route? Our pilots, I would say, OpenSea are very educated, because we make some project where we force our pilot to adhere of some time, etc. You know, Alex, very well what I mean. And OpenSea, and I'm very, very surprised what the acceptance by the pilot. Because at the time, they understand why they have to do that and see the result. They never ask again why before it was better. The only question that I receive is why we are not able to do it the rest of the day.
And one of the other things, of course, that we observe is that not all airlines are as good at that. Some airlines don't file particularly good flight plans, and they may not have anybody in their ops section to optimize the flight plans in the same way. So there are kind of different behaviors between different airlines, of course, as well. And that comes back to how do we make sure we've got a level playing field somewhere in the game. Roland.
One question from my side to the panel. We are all aviation guys, but I question myself, is it a good view, which we have, a good perspective? Because at the end we are doing something for the society, and maybe you have some input from the external world, from the society, who might give you an input how we can change or what would be necessary. Because at the end we are working for the citizens, at least at the as the ANSPs, and everything is done by the transport sector. And that's not to blame somebody, it's the regulation, it's by the transport sector. Our job is by the transport sector, so we are optimizing our system internally, and maybe you get some insights, maybe Mathieu or Geoffroy, from your discussions in France, where you can learn something from the external world.
Should we pick that one up, starting with Mathieu, please?
Well, thank you, and thank you for the question. Well, two examples. The first one, the multi-annual program around Schiphol, we consulted that with local communities. And I think it's really important to get feedback, because we don't know what's best. They are living there, we want to improve the system. So you have to discuss that. I think that's really important. And it's not always easy, because what I said before, what's good for one community can be a little bit worse to the other. So I think it's really important to keep that in mind, that you're not the decision maker there. As an ANSP, you can make the different scenarios. You can show what the results are. But at the end, the decision making should be done at the ministry level, because they have to decide. At LVNL, I'm not choosing which one is the best. So that's one thing. And then another thing is, because of COVID, we re-examined our project portfolio. And we did that not by ourselves, but we consulted as well our stakeholders and asked them what are the criteria. So we did that with airlines, with the ministry. And what they came up with, and we were really happy with that, is that also sustainability and noise pollution are high on the agenda. As well, it wasn't said before, but as well, of course, first safety, continuity. But it's one of the criteria where they asked us, look, if you're looking at your project portfolio, look also at those aspects. So I think it's really important to consult your stakeholders, to talk to them on a regular basis, so to keep that in mind.
Thanks, Martin. Jeffrey, coming across to you with the same question then, how can we make use of the external inputs?
Well, it's a good point. I can give you two examples in France and quite recent ones. There are political decisions and a law coming in France which totally forbid the flight from Paris Orly to Bordeaux, for example, because of the time difference between the train and the flight to go from downtown Paris to downtown Bordeaux. On my side, it's awful because I'm going to go to the Bordeaux airport to work, so I have to take the train downtown, then take it back. But this is a political decision. This is the society who wanted it. And we have to take it on board. We can think what we want about this decision, but we have to take it on board. And this is part of the deal and the sustainable way to move forward. I'll give you a second example. We go to this commission with the airports, the communities, the airlines, and the ANSP to discuss departure procedures. And the way we presented them, we show them until flight level 90 or 100. And then suddenly they say, well, but you don't follow what was published because you give direct routes before, and how come you do that? And we say, well, it's because of the capacity and we want to save CO2, so we give direct routings as soon as there are clear conflicts. And say, well, no. We want to have the procedures followed as presented to us and as published. And this is the way we can build confidence between us, build trust between us. So now the ACNUSA, which is a separate entity which only focuses on the environment, told us, well, you have to respect these procedures, so don't give direct routings anymore. And we have to explain that to the airlines. So it's part of these political decisions, the way society wants us to move forward, and we have to take them on board. So yes, indeed, it's very, very important, and building that trust is very important.
Thank you, Jeffrey. And we've got time for one more question, I think. Mohamed.
Thank you. How does it work?
I think you're good.
It's good? Okay. Yeah, as an IFP and airspace design expert in Skyguide, actually, I would like, again, to highlight these last 2 points about the locals. How do we convince them to implement new trajectories, to change, especially the one in the TMA? Because these are the ones to change, basically. We are talking about 97% for the horizontal perspective. What about the vertical one? And this is where we can change. We have the criteria as an IFP designer. We are willing to design new trajectories using the new criteria, using the new performance navigation. The aircraft are equipped. The airlines are willing to help us, ATC as well, all of us. But there is this last step, community and politics, which is extremely challenging for us because we have to design different scenarios, different IFPs, explain which one is better, by how much, by what aspect, and then go with this campaign. And so far, as personally speaking, what we see is that basically if we have to implement the new PBN IR, which is basically to transit from the conventional procedures into the RNAV, we are keeping basically the trajectories as they are currently. So there is no benefit. We are not taking advantage of this benefit of PBN because no one wants to change these trajectories in the end. So we are willing to improve, but in the end, we cannot. So we need to make sure that somehow the community is aware of the challenge that we are facing, and we need to find a compromise between like changing the trajectories and implementing new ones that will be more environmental friendly, and also to improve also capacity, because our aim is not only environmental, it's safety first, of course. We want to keep the capacity, and we would like also to improve the environmental aspect. That's the only point, and we don't have an answer to that so far. It's very challenging, and it's very cost-effective, because we extend our projects by years to define new trajectories and go with this campaign. It takes ages before we do that, and then in the end, maybe it doesn't even go implemented.
Certainly name a few examples of that as well on the way. So looking at the sort of Jeffrey and Marcia for any comment come back there. What do we do? How do we raise the benefits that we could create with these new routes? Because undoubtedly we could create new benefits, but we then hit the other side of the environmental question, which is the noise question.
Well, I recognize the problem. Let me start with that. What we're doing is we discuss every measurement by measurement with the local communities. And sometimes it works out, and sometimes it doesn't. And sometimes it's frustrating, because we're using our scarce resources into those projects, and we are convinced that we can make it better. But sometimes it is what it is, and sometimes we're successful and sometimes we're not. And for the Dutch airspace redesign, we really also ask for a boundary. So that means that we have the boundary of 6,000 feet. Under that boundary, it's noise, and above that, that's CO2. That helps our airspace designers with the design. But I agree with you, convincing the local communities, convincing the politics, it takes time. At one hand of the situation now, and at the other hand, there are coming, innovation will come up, and that will bring a certain uncertainty with you. So sometimes we all know what we want and how we can achieve that, and sometimes, we don't.
And what we presumably, in our experience, we don't see that often where the politicians step in and they then say, we'll take this decision and make it happen. We had an example in Paris where actually that did happen after the appropriate consultation process has been gone through. But that's actually probably rarer rather than more common, certainly in the western part of Europe. And I think that's one that will be accompanying us over the coming periods as well as a big question. Maybe also at some stage the green agenda will raise the need for the political intervention in a way that's just completely different to today. In some ways, I hope that we get to that. I've got one last question for you, Mark, as well. We talked about it a couple of times, but the network manager's been kind of in the discussion, but not actually addressed, because we've been talking about the network view. So how would you go about integrating the network manager in what we've discussed here as well?
Well, easy solution from a oral point of view. The network manager gets a political instruction that he manages the network according to green trajectories. That's it. And then from there on, you will then, of course, get into the complication of how do you make that first come, first serve, because it's the first time I hear that airlines are calling for something else than first come, first serve. So that there is a shifting of how you manage your network, and then also you give a completely different rule of how you manage the network to the network manager. That means, however, that the ANSPs then have to follow what the network manager tells them. So if we want to be really radical, so go towards the green agenda, you can do it.
That's quite a big idea, isn't it? With one or two obstacles on the way. But what actually is important there is less than finding the obstacles, but also saying if you did that, then you could actually achieve what you're trying to achieve, and that's always a good and useful place to start from as well. Ladies and gentlemen, I'd like to thank you very much indeed for the panel session and for your various inputs in the different ways. And I'd ask everybody to give a round of applause to an excellent panel. Thank you very much. That then brings us to the last part and to the wrap-up of the day. And if you'd like to go and take seats, then you can at least listen to the last part slightly more comfortably as well. Céline, do you have the handheld, please, for Marcel too? So we've had for a day that, for me anyway, has been extremely interesting. I've made lots of notes because I've learned a lot on the way through the day. And there's a lot of things to think about now as well, because it's changed my perspective in quite a few different ways. to then say, okay, what about this, and what happens if we do that? Or do we, at some point, and if so, who and when, decide to turn these things upside down and look at that completely differently? Marcel, what did you take from today?
Yeah, thank you very much, Alex. For me, it was a very interesting day. I learned a lot. I think we had a very good exchange of views and ideas, and I have maybe 4 points. Well, first, it's not a surprise, but environment doesn't stop at the border, so we need to have solutions really in a bigger environment. And I think FABEC, and as we heard this morning also from Regula, FABs may be one of the platform to have such solutions and to exchange practices and to implement cross-border solutions. So as FABEC is in the middle of Europe, I think we are committed to have a contribution, a big contribution to this environment topic, and I'm sure we are able to improve the situation. Then I also learned that we are still a lack of data or metrics, whatever. I think here we should also improve, but don't forget we cannot wait until we know everything. If I may do this comparison, sorry, with the vaccine. The effectiveness of the vaccine, we don't know. Maybe it's 90%, is what? It's 97%. How long will the vaccine last? 6 months, 1 year, 3 years? We don't know yet. But we do the vaccination now because we know that we need it in the pandemic. And I think it's the same with all the projects ongoing now in the FABEC. We need to speed up. We need to implement what we discover. And then maybe something new for me was that the weather is playing a big role in this environment issue. And I think that we should, and I will discuss this in the FABEC Council and in the ANSB this week, we should look at this point maybe most carefully. I think there is something we could improve there. And then last point, maybe, safety is always first. Safety first, that's not the point. But I think when we are thinking in the past years, we spoke about capacity and cost efficiency, the big topics. And I think when we think about capacity, we should keep in mind that environment is also important, and maybe we should improve a little bit or put in environment maybe on a little bit higher level when we are looking at RP3 or RP4. That's my conclusion. Thank you very much, Alex.
Thank you very much, Marcel. And I always like to hear a regulator and a national supervisory authority who puts safety first as well. That makes me feel much more comfortable too. But that's a reinforcement of what I've been hearing and what I've been thinking as well today. And the key takeaways there are absolutely on my list. I would maybe add a couple of ones about the fact that we have got some achievements. We've got some things that we're doing, and we should make sure we do those and deliver them. And I think the commitment to deliver more into the future is going to be very important as well, on behalf of FABEC, but actually on behalf of the whole system. And we come back to the point about the system there as well, and the fact that we need a lot of people to be collaborating in that system to make this work. And that's therefore where we probably need to start, is not wait for anybody else to do that, but to start working out what it is, who we need to talk to in order to improve the situation. And with that, we come to the end. I'd like to thank all of the presenters. I'd like to thank the panelists. I'd also like to thank Geneva Airport for the use of this room, of course, which has permitted us to be here in a little bit more comfort than if we were all in a very small room. Like to thank the Comcell for the organisation and the back office team, the AV people. But most of all, I would like to thank all of you here and you at home for joining us as well and making it a lively conversation rather than just a set of presentations and that was that. So for those of you at home, I wish you a very good movement from one room to the next room, and for everybody here, I wish you a very good and safe flight home. Yes, thank you very much.